So I'm going to do this a little bit different. I want to say thank you. I've been doing this for a number of years, and I want to say thank you to the Bradford Cooperative and the Muck Crops vegetable growers, OMAFRA. Special shout out to Matt Shepard and Dan Sopak. Shawn and Kevin and the crew here at the station have been a real joy to work with over the years. So very, very grateful for the help and the support that I have received over the years. I also like to give us some background a little bit. Because of the work that we've done here, we've been able to achieve some registrations over the years. And just highlight the outcome from the Ontario Crops Research Centre here. We were able to get dual registered, Prowl, and Blazer registered for use on carrots. So that's some of the outcomes that we've been able to achieve. We also did some work here on establishing the critical period in carrots. And we published this, and really it's about keeping the weeds clean, the carrots clean until the 8th leaf stage. That's your yield window from emergence to the 8th leaf stage. That's the yield window. After that, from the 8th leaf stage, we're going to, by the 10th leaf stage, we should be nearing canopy fill. The canopy is the most important biological weed control measure you have. And then after that, it's really about harvestability. Is there going to be a harvestability problem? So that's the time frame from emergence to the 8th leaf that you really need to concentrate on keeping clean. And then with Kristen and we published a paper on best management practices in carrots. So this is some of the outcomes that we've achieved. But I want to highlight today the work that we did in 23, the work that we did really as a setup for the future, okay? And I want to talk about chemistries that I'm completely confident can be a benefit to carrot producers here in the marsh. So we had 4 trials this past year. We started out looking at acetochlor, which is a product called Harness. It's sold in the States. It's a product like Dual or pyroxasulfone. It's in the same family. And we thought that was going to be registered. So we spent the first trial was really focused on that to see if it was safe on carrots and on the muck. And we did that. And then, and since that time, we've learned that it's not likely to happen. So I'm going to briefly mention the trial. We also looked at the tolerance of onions to a product called diflufenican. And that product is a brand new herbicide family. Really important for us for the future here. And I had to confirm that it's going to be safe on onions. Then we were able to do an on-farm trial and with marshland growers, gardens, and we put some extreme treatments out there that we weren't able to test on the station. And then we looked at it, put out a trial that said, what happens if we lose linuron? And what happens if we lose the triazines out of the carrot market that we can do? What happens then? Can we survive that type of hit? So I want to show you, these are the types of works that I want to show you. And I just want to profile the chemistry that I'm going to talk about. You've already had some experience with Tough. This is pyridate. It's a group 6. So this is the same grouping as bromoxynil, as partner. Okay, it's in the same chemistry as partner, but it is very, very safe on carrots. And we'll talk a little more about that. The other product that I'm excited about is called metobromiron, which is Praxum. That's the commercial name right now. It's a group 7. It's in the same family as linuron. Okay, so it's not necessarily going to control linuron-resistant pigweed, but it is a replacement. Could be a possible replacement around linuron. And then Blazer and Goal in the group 14, and Kristen's going to come and talk a little bit about issues around group 14. I also want to highlight in my talk, so you don't get confused, some of these treatments, diflufenican, we're going to code it as DFF, so I don't have to keep saying that complicated name. And Praxum and Zidua and Harness and Dual, we're going to talk about them going on post-emergently, okay, over the top of the carrots, but we're really putting them on post-emergently for their pre-emergence activity. They're not going to control any established weeds, okay? So keep that in mind when I talk about post-treatments versus pre. When I talk about pre, I mean the carrots aren't up, But if I talk about post with this, this is really about determining if it's safe to do it over top of carrots, and they're trying to get it on the ground for safety. So we had our experiments here. Peter was up here several times spraying to get the work done for us. And this is our standard treatment. Most of our work has been done on cello bunch, seed at 25 seeds per foot or 30 centimeters, 4 replications. The other thing that I want to point out is about the herbicides here. Our spray volume. This is 200 liters per hectare. That's 21 to 22 US gallons per acre. Okay, so herbicides need low volume. Okay, there's no sense carrying extra water out there for herbicides. Okay, different story perhaps with your insecticides and fungicides, but certainly think about 200 liters per hectare or 20 to 22 US gallons per acre. And then we did the rest using the best practices that we could. So I'm going to highlight this work. So this work kind of got negated about a month ago because we learned that acetochlor was not going to be registered in Canada. Okay, so anyway, we had all prepared thinking that it was coming. So, but I just want to share with you that it's out there and that what we did. So this is a product that was is sold in the States as harness. And so we put it on like before the carrots came up, and we put it on post-emergently on the cotyledon stage to the first leaf stage. And we did so at rates of about 1,000 grams active all the way up to 2,500 grams active. It was safe, okay? Did not cause us any problems. It's good selectivity. And because we looked at this, we thought it was going to be mixed with that diflufenican, and it was going to be a combination that could be very, very useful for us here on the soils. So I just summarized that, what we found with that product, rather than show you a lot of the data, but we had it up to 2,500 grams active, safe, so we had quite a range of selectivity. We mixed it with Hardner as a stale seed bed approach. That worked very well. Excellent crop safety when it was tanked mixed with the DFF or Praxum and applied post at the bunny ear leaf stage, and no significant differences in yield. So it kind of got negated, as I said. Just so you know, this is the work that we did with the money that we had. And anyway, it did show very good selectivity on carrots for us, something for down the road. The second trial is looking at this DFF, this diflufenican, which is a Bayer product, is being marketed specifically for control of resistant pigweed, okay, and water hemp and the pigweed species. We have tested this since 2018 at a wide range of rates. We have shown it's to be very, very selective on carrots. It's very, very good. And so in 22, we set up a trial to have a plant back of onions. So this is the trial in 22 where we tested this product. And this is the results in 23. So we had good follow-up, good rotation. There was no impact on the carrot from the residual of this product. So important to know. A word of caution, this is 1 year of data that we have here. And we've only tested onions. I don't know anything beyond onions at this point, okay? So if any of the other crops, this is only relative to the onion story that we had. So this is an example of what we had. So this is the diflufenican product, and we tested it prior to carrots here at 60, 90, and 120. We tested it post-emergently at 60, 90, 120. I just cut that one out because I wanted to get to this one here, as high as 180, okay? And carrot leaf stage, when we tied it, this is when we applied it in 22, this is at the bunny ear stage to 1 leaf, and here 1 to 3 leaf post-emergently. The onion stand, there was no significant difference in the onion stand, and we did not have any significant difference in onion yield. So this is exciting because this, as I want to stress the fact, this is a group 12 herbicide. So this is entirely new chemistry that could be very effective for us to use and give us something new in the carrot market. We were fortunate with Dan Sopak to be able to put a trial out on his farm. We put out 10 treatments into his commercial operation there, and I'm very grateful for that. And we tried some of the treatments that I wanted backup that we had on the station. So we actually had 10 treatments, and I'm only showing 7 of them. But again, this is pyroxasulfone, this is Zidua, this is Praxim. These two in combination, I want to highlight, are extremely effective treatments on carrots, okay? Very effective to use in the future. And we tried it with Agro 90 to see if we could get some burn out of it, okay? Keep in mind, this product is in the same chemistry family as Linearon, and so, but it doesn't have any post-emergence activity. This is a pre-emergence only, okay? And here we had, this is the product that I thought was going to be registered, so we put that in. And then we added this to metabromiron pyridate. We played with all kinds of combinations, really to see whether there's anything that would cause us problems. For the future, because acetochlor is not likely to be here, you could think about Zidua being here. You could think about a dual product being here in this combination. Very, very strong and helpful here. So this is just an observational trial. So I want to show you this, what Praxim does. So this is metabromiron, group 7, same as Linearon. But here are the weeds that are on the label that are relevant to us here in the marsh. And so it has a fairly large spectrum. And you're getting, it's hard to tell, 10 days residual in that ballpark, depending on what happens. So it is a very effective there. It has good activity on, if it takes out a pigweed, it's got to be probably not the resistant pigweed. So let's assume that a resistant pigweed is still going to escape this, but it also has a broad spectrum that helps us here. Sorry, wrong way. And diflufenican has a smaller list of species, but it is very, sorry, push the wrong button here. Oh. Yeah, diflufenican here, group 12, but it has very good activity. This is how they're going to market this pigweed complex here, okay? And this is why you'd want to chase this one down, okay? New herbicide, new mode of action, and very, very good on the pigweed story. So that's something for the future. But you see, it also has relevance too to us here with some of these other weeds that we may see from time to time as well. So there's a picture here. So all of those treatments, we had 10 different treatments. I talked to Dan and he said everything went fine. The harvest went well. And then he continued with his treatments over top of this as well. So keep that in mind. And they were very, Dan didn't have a problem with anything that we did out there. We tried to clear out any weeds that did escape it. But keep in mind again, that we tested this over the carrots, and most of these products, with the exception of a few, are really on there for the pre-emergence activity. So anything that escaped was not controlled at the time. But again, some promising results. So that was a dry season. In this particular field, we had rather uneven emergence of the carrots. And that was helpful because it gave us a range of carrots at different stages that we could test to be sure that we were safe on. And I want to, again, highlight here a little bit that the best treatments tended to have these two products in there. So this has got residual, and this has residual, and this would take over the resistance story, pigweed. This would give you broad spectrum weed control in here. And keep in mind, again, I stress that these were applied post, but really for that pre-activity. So lots of backup to ensure that we're okay. And then finally, what I want to talk about, we're flying through here, I want to talk about is what do we do if the scenario turns against us that we lose Linearon and we lose triazines? How would we manage? Okay. So the good news is we can. Okay. I just want to show you this. All right. So we set this out, and this is 1 year of data. Again, 1 year, one site. So keep that in mind when we look at this data. But asking that fundamental question. And I do this so that we can show that what can be done if these things happen. This will be on record. These trials will be on record, and we know what products we need to work towards to get these products available. So I want to start by showing what we did, and I'm going to talk about application timing because that's so critical. I use here what I call a pre and a late pre. The stale seed bed approach, right, at the very beginning. I want to stress the importance of keeping the weeds under control prior to the emergence of the carrot, okay? So in this case, if we had a triazine, if we had prometrine still available to us, we put this on the treatments, and we did so as a pre, and we have about, say, 10 days before the carrots begin to emerge. So probably around day 6, we went over the beds and applied what I call a late pre. So the idea is you don't really necessarily see any escapes, but if they're there, we're going to try to get them, but they might be just coming through the ground, okay? So the goal here is to keep that very, very clean. I also say that because of the work that we're doing on field crops, where if we're looking at corn and soybeans, if they see green tissue when they emerge, their physiology changes quite a bit. And I'm sure that probably happens in carrots as well. So I want to stress that. And then you're going to see post 1, 2, 3, and 4 in these treatments, trying to keep the weeds out until around the 8th leaf stage of the carrots, okay? And then after that, we let the canopy take over from there. So that's just so you see these treatments, this is what it looks like, okay? And I'm going to just focus on, we did 16 different treatments, okay? And I'm not going to run you through all 16 of those, so I'm just going to focus on a few to show you. And I want to highlight Tough here. And I do so because of its safety. I know that some of you tried Tough. I think some growers were not terribly thrilled about it. Some were more successful about it. This is for small weeds, post-emergence, okay? The things that are relative here in terms of weed species are black, red root pigweed, common lamb's quarters, wild mustard. This is the group 6. So pyridate, Tough is in the same family as bromoxynil. So we tank mix it with bromoxynil because bromoxynil or Pardner does not control pigweed very well, okay? So if you're using Pardner over your stale seed bed prior to carrot emergence, realize that pigweed you're vulnerable to pigweed escaping there, okay? So if we tank mix this with pyridate, we're picking that up, those smaller weeds up early on. And I want to show you here how safe pyridate is. So this is pyridate applied, and this is the formulation we use, applied post-emergence, the bunny ear leaf stage, okay, as early as we could. 300, 450, 600, 1200. Wide range of dose range. This is the commercial range, is likely to be here, okay? But just so you know, it could be higher, but this is where it's at. So this means you can also apply this more than once, okay? Now that gets into resistance management, and that's another discussion, but be aware that we applied it early here, the 1 to leaf, bunny ear to 1 leaf stage. It could also be applied at the 3 leaf stage as the needs required. But again, I stress about the resistance issue if we keep repeating the things. And here's your metabromiron. We put that in as a point of comparison. Okay, so very safe. That's what I like about it. And it does have activity provided the weeds are small. So here's pyridate. This is not this year, but this is the previous year. This is at 1,200 grams pre-emergently, right? Now, the problem with a pre, if you put it on a stale seed bed, like prior to the carrot emergence, right? There are several things that are a problem there. Is if the weather gets cold, like if you put dual, say you sprayed Pardner and dual and pyridate on before the carrots emerge, just to keep that seed bed clean. The carrots in 4 out of 5 years will emerge through that just fine. There can be a year when it gets cold. And if it gets cold and wet, there's always the possibility that would delay emergence or cause uneven emergence with a pre. So I like to see the seed bed controlled by non-residual like Pardner, pyridate, just to keep everything there until the carrots get up. Then we put the residual on, okay? But you can do it both ways, and it will work. But again, it depends on the weather and the conditions of the weather. Like outside today would definitely causes problems, right? Okay, so just keep that in mind as an option. But so this is 1,200, and the stands were fine, and the yields were fine in these trials. Here's pyridate post at 1200. Okay. This is metabromiron. I couldn't believe the residual control we got out there. I took the board members out to see this. This was amazing. And I'm not sure how long we get residual control. I'm going to say 10, 12 days. It could be longer than that. We're not supposed to get any residual control in high organic soils anyway. But so this is at 1,000 grams pre-emergently. And you can also use this product post-emergently. And we cut the rate back to 500 grams. Okay. Now I could have put 1,000 on there too, or I could have played 500 and 1,000 or 1,500 just to show you that this is good. Put the lower rate on post-emergently because we got to be sure at the end product that we don't have unnecessary residue in there, right? That's the other issue we have to think about, especially if we're shipping internationally and stuff like that. So this provided broad spectrum weed control. I'm not sure if it is effective at all on the resistant pigweed species, and I'm going to guess that it's not, but it certainly has good selectivity and it's safe on carrots, can be applied early, can be applied later in the carrot story as well. And I just want to highlight that we got this registered Blazer. I was a little anxious about this registration because we had never tested assist with it before, but 23 grams active. And I'll tell you, I'll convert this to mils per acre at the end so that you'll know what to do here. But this is Blazer, 23 grams active with assist, and we did not have a problem. Occasionally, things like Blazer and Gold that we used can cause slight burn, but I'm asking you to live with that slight burn because you're getting the control of the weed species, okay? So we have to be careful about the demands we place on the chemistry. Now, this treatment. So here's an example. If we lost linuron. So I'm going to walk you through slowly on this just so you see what we did. Okay. So this is Geesegard, put on pre. And then I followed up with Partner plus Tough as the late pre. Going to keep that bed clean all the way through to the carrots emerge. Once the carrots emerged in the bunny ear stage to first leaf, pyroxasulfone plus metabromiron, that's Zidua, plus Praxum, post-emergence. I'm amazed at the tolerance of bunny ear carrots. When we first tried this, we sort of sprayed, then close your eyes because you figure you're going to burn the whole crop, right? But it has surprising tolerance. Okay, so this is put on at 500 or 1,000 grams active of that Praxum. Okay, and that's going to give you broad spectrum control. And this is a product of choice in many treatments for me. That's Zidua. I like that on the marsh. This is good. And this one, the other aspect to that is where very few weeds have developed tolerance to that chemistry of pyroxasulfone and dual. So you could replace this with dual as well, or Zidua. And we were thinking about acetochlor being there as well, but it's not going to be there. So we put that on post. And then we followed up with Blazer plus Tough at the like 1 to 3 leaf stage. Blazer's a little more tender. Oh, that's not the right word I want to use there. It's a little more easy on the carrots in the early stages than is Gold. Okay, so the first treatment should be Blazer. And you can tank mix that with pyridate to help it pick up pigweed. The rate that is registered, keep this in mind, the rate that is registered with Blazer is for pigweed only. That's all you're doing with Blazer, okay? So it's specifically, it's what we call a biologically effective dose to take out 95%, 90% of the pigweed, provided they're small. Pigweed will escape this treatment here if they're large, and large being over 3 leaf stage. Okay, so you got to be fairly small there. And then we came back at the leaf stage of, just a moment, I got to check that. Yeah, we went 1 to 3, 3 to 5, and 5 to 7. We came back here and sprayed Gold, which we do at the later stages. And then at 5 to 7 here, we put a final dose treatment of Tough, Gold, and clethodim on. And those treatments, I mean, weeds were starting to skip. I'll show you in a minute that things were starting to move a little bit on us, but that was a promising treatment if we lost linear. Okay. The only difference in treatments here is here. We added to peroxysulfone, we added the diflufenican product, the DFF we call it, okay? And that was very effective as well. Otherwise, everything else was the same. So those were promising. And as I said, we had 16 different treatments. I would put you to sleep if I took you through all 16 of those. But that would be promising treatments if we lost linear. Okay. Now, the next part of that, what if we lost prometrine? What would we do then? Okay. So I'll show you two possibilities. There are other ones. Here we had, now we don't have any prometrine early on. This is strictly post-emergence control over the steel seed bed. Again, we tank mix, but partner, I stress, does not do an effective job on pigweed. And so we add pyridate to help pick up the pigweed that might be there in a few other weed species. We use that, we could use that once, we could use that twice if we had to. Okay, because there's no residual with it. Will not influence emergence. It's good. And then again, we go back to pyroxysulfone, which is Zidua, plus Praxum, metobromiron, and then we follow the same type of pattern again here, keeping, and then go later in the story, and then finishing off with that kind of combination. Now, there is a problem with that system, and that problem lies in we're using pyridate. Okay? That's a problem. Okay, so we're going to have to watch that and how we balance that. This group 14 is resistance creates problems for us down the road. But I'm hoping that if we can do this, that's going to solve the group 14 or the resistance to the goals and the blazers and solve that problem for us here, because oxyfluorofin, acifin, and I don't want to see us get into more problems with this. Pyridate, I have to backtrack. It's not a group 14. Pyridate. We have to be careful about how many times we use that. That's related to bromoxynil. But here we have oxyfluorofin, we have acifluorofin. Those are the group 14 treatments that I meant to say. So the difference here is we went from metobromiron here, and again, just showing you with Zidua, we added that DF product, and that gave us good control and good results in these trials. So the reality is we can handle resistance. We can handle some of these changes if they come down. We just have to get some of this chemistry up front and center and registered for use. So this is what these plots look like at July 18th. And so there are 16 treatments here going on, 8 across each rep. And here's what it looked like on August 1st. And we're starting to get some weeds coming through. There are some weeds coming through in there. But we did no manual control. We did no cultivation. This is strictly the chemistry. And by August 1st, this is what it looked like. And we have tons of weeds in the soil here. Okay, tons of weeds. Okay, so was it perfect? No, but it was pretty darn good given the situations. Okay, so some promising results. Again, we just tested it last year for the first time, and the intent was to show that there's possibilities to handle as we move forward with some of these changes. So in summary on these trials, carrots resulting from linear and triazine weed-free management strategies did not differ significantly from strategies containing both linear and triazine herbicides. No significant differences in stand counts or crop yield were detected among these treatments. Tank mixtures with tough Zidua, Praxum, and DFNF demonstrated excellent crop safety in 2023. I have complete confidence that these trials, that these herbicides will be a huge benefit to carrot growers if we can get them registered, okay? So here's the breakdown. Here's what we did, and this will be available. I can make this available for anyone. I'll pass this on to Matt as well, and he can distribute it. But these are the rates in mils per acre that we used. Dual Zidua at 71, dual at 480, goal at 100 mils of product. This is product rates. Linear and Blazer, Tough, Praxum, and diflufenacan. This is, again, an estimated commercial use pattern. I'm not sure what they'll come in at exactly. So with that, so a couple of summaries. Minor crop registration is where we got to go. We got to be sure that we get companies on stream, those that will help support. And how do you choose in among here, because they're all needed. And so what order do we do this in? And what order can we get companies to be supportive? Another recommendation is you start clean and you stay clean until the 8th leaf stage in carrots. And the golden rule is big yields, you got to be controlling small weeds. If those weeds get too big on you, they're gone, and we'll have to come in manually for them at that point. With that, again, I want to say thank you for your help and support over the years, and I hope this information can help us be very successful as we move forward into the future. Thanks very much. Go.
Do we have any questions for Clarence?
There's one online from Kristen. She's asking if you could comment on the difference in pigweed control between dual and Zidua.
The work is really focused, Kristen, on crop selectivity. I don't have that data in my head. So I'm not sure what the differences might be. I'm sorry, I don't have that.
And there's another one from Chris Stoivelshoff. He's asking if you have any experience with the herbicide clonophen sold as a merger in Europe, Group 32, with pre and early post-emergence registration on carrot. Product is not registered in Canada.
What product was that?
Clonophen sold as a merger in Europe.
Not familiar with it, no.
Okay.
So no experience.
Margaret, I couldn't count fast enough that year for best weed control is about 5 trips across the field.
Yeah. Yeah. Yeah, it's a busy schedule. Yeah. There's no way around that. No. So yeah, it's costly that way. And you know, weather can influence the activity on those herbicides, right? So you're still going to need manual weed control. That's got to be at some point part of it. This is going to take you a long ways along the road, but I'd still be prepared that you're going to have to walk fields, especially around the resistance story. We haven't done this. It's not been tested on mineral soils. This has been strictly on the muck soils. That's a whole other basket that has to be taken over to the mineral soils now and just confirm these results, that it works as well as it does here. Yeah. So it's a kind of a snapshot of what could be. Okay. With that, we're good.
All right,
Thank
before
you
you
so
go,
much.
Clarence,
Oh.
on behalf of the research station and I'm sure all the growers, we'd like to thank you for all the work you've done the last 20 years here. And I'm pretty sure this will be your last presentation that you'll do to our growers, but on behalf of everyone, I'd like to thank you for all the work that you've done for us. Thank you. So our next presentation is going to be an update on some of the resistance management tools that we have available. And it'll be Kristen Obeid, our Omafra weed specialist. She's going to do a virtual presentation. And she can start whenever we get it loaded here. Welcome, Kristen.
Okay, thanks very much for the presentation, Clarence. It's a good setup for just kind of going over what's been going on with the resistant pigweed situation. This is some work that both myself and Dennis Van Dyke did in 2021. I'll talk a little bit about that, as well as what our current resistant weed situation is, what we have available right now, what would be a good program for you, and what some future options are. Clarence spoke a lot about those already, and then talk about some new technologies. I just have a bit of delay here with my slides, so just give me a moment. Computer's a little slow. Sorry, folks. All right. Here we go. Okay, so right now in Ontario, we have 23 different weed species that have varying levels of resistance. The most common trend we're seeing is that weeds are becoming multiple resistant or resistant to more than one herbicide group. Over the past couple of years, we are now seeing resistance to group 14 herbicides, which has, in horticulture anyways, these have kind of been our newer products that have been integrated into our programs to really help with some other resistant issues, primarily to the group 2s and group 5s and 7 herbicides. Yeah, and so the biggest issues that we're facing are the group 14 resistant pigweed species. This was first detected in 2021 in Lambton County, and now we've also detected it in Chatham-Kent and Simcoe County. So it's going to be a real challenge ahead. You will note on this slide that I do not have any group 7 resistance anymore. And the reason for that is the Herbicide Resistant Action Committee has moved all of the group 7 herbicides into the group 5 herbicides. So they say that they act similarly enough that they've moved them into the group 5s. So we used to have what we would have called three-way resistant pigweed species, so to groups 5, 7, and 14 here in the marsh, but now they're just calling it group 5. Okay. So I wanted to just briefly show you quickly that in the Ontario Crop Protection Hub, if you go to the weed control search and then toggle on the left-hand side herbicide resistant weeds database and maps, basically, and then click on here, you'll see the database again highlighted as a big, I guess, text box there. Click on that and it'll bring you to all of the herbicide resistant cases in Ontario. They've all been entered into this system. So you can see there's over 1,700 cases, and you can find out if you go over to the left-hand side, you'll see here a little arrow. And what you can do is you can input what weed species you're interested in finding out about. You can put in your municipality or county, and you can see what species are resistant within your area. You can also, it'll give you a breakdown of how many are of that species is resistant, like to one herbicide group, to 2, to 3, that kind of thing. And this here is just showing across Ontario. I put in for red root and green pigweed. You can see the number of cases and how many are multiple resistant. I have highlighted here just the 3 municipalities or counties that have group 5 and group 14 resistant pigweed. And this map is hot off the press. You can see here, this is what we've found so far. And really, we have not done a big survey for group 14 resistant pigweed species because we just sort of started finding out about it. I suspected it on a farm in Lambton County for about 5 years and finally picked it up in 2021. And then last year, we just decided to actually test for it. Some of you may know that I have a genetic testing program, and we just developed the group 14 resistant test. And so we decided whenever samples go in, I have the lab test them for all the herbicides we have tests for. And so that's when we started picking up group 14 resistance. And it's also been picked up here in Simcoe County. Like I said, we haven't done a full out survey. Like if you remember, when linear on reverse resistance was a big thing back in 2012, we did a big survey of all the farms here in the marsh. We have not done that here. And so just to give you an idea, this, in Lambton County, it's one farm, multiple fields, Chatham-Kent, multiple fields, and in Simcoe, it's in multiple different farms and fields. So in the future, we really should do that testing to find out really what we do have. These pigweeds are going to be an ongoing problem. In Ontario, for example, we have 5 different pigweed species that are resistant to multiple herbicides. And the trend is they just become more and more resistant to more and more herbicide groups. So we need to prepare ourselves for that. A biggest concern for this crop production systems are the red root and green pigweed. But across Ontario, water hemp has also become really problematic for many different crops. We've picked it up in horticultural crops, just not in carrot and onion producing areas yet. But the common water hemp is 5-way resistant to 5 different herbicide groups in 8 counties, overall found in 18 counties or municipalities throughout Ontario. So this one is going to be problematic in the future. We're going to need to watch for that. In this past season, also Palmer amaranth, I'm sure you've heard about that amaranthus species. It was found on one farm in Middlesex County this year and was found to be resistant to group 2 and group 9 herbicides. And just for your awareness, group 5 resistance was first picked up, for example, in Ontario in 1977. Group 2 in 1998, the group 7s in 1994, group 9 not until 2014, and that was only with water hemp. We don't have any glyphosate resistance green or red root pigweed yet in the province, but then also resistant to the group 14 was picked up in 2018 in water hemp. Okay, so now we're seeing that trend into the pigweed species. So we all know what resistant weeds means when we can't control them with herbicides and cultivation and other means. We do have to get out there and hand weed. And the weeds actually really do need to be removed from the fields, because these large weeds will still have viable seeds and they will just be returned in the seed bank to continue to cause problems in the future. So we also know that then, maybe weed wicking is an option. But yes, not only the weeds are over the canopy and in some cases already have seed on them. So that is also not really the best strategy going forward. So what are our current registered options in muck soil? Here you can see them, like Clarence alluded to, since 2012, have been successful in registering Prowl, Dual, and Blazer. Blazer is the most recent one. When Dennis and I did that large scale on-farm 6-acre trial in 2021, Blazer was not registered yet. But I just thought you'd find this interesting, because we were really challenged to find out what is the best option for the grower at this location. And so you can see here is the treatments that we applied. We did several pre-treatments June 1st, then we went in with basically a rescue treatment on June the 30th with Lorax. And I've highlighted that Lorax rate of 1.8 liters per acre because that was the before rate. Now we have a much reduced rate. If we went in with just one post-emergent application, it would be half of that rate now. And then we had in treatments 3 and 4, we also did a second post-emergent application. And here you can see what the pigweed pressure looked like at that location 28 days after our pre-emergent applications. And this is when we went on with the full rate of Lorax across all of the treatments. We thought we were going to lose the trial, but after that and after the other post-emergent treatments, here you can see what the field looked like. And here you can see these are where the different treatment numbers were. And say overall, there was no significant differences in yield between any of the treatments. But what we did find, and there was no significant difference in carrot stand counts. You could see there we were using, like Clarence was talking about, applying the pre-emergent products before the carrots emerged. We applied a 3-way tank mixes that did not have any impact on the overall carrot emergence. We did find that the leaf stage, though, was greater for the carrots in the Gezagard dual prowl treatment, as well as there was visibly less, and we counted, the students hated us, but they counted all those pigweeds and a total per treatment in many quadrants in each one of those large plots. And we really didn't, there was less pigweed species and total weed species in the Gezagard dual prowl and plots in both 14, 21, 28 days after application. And like I said, there was no difference in yield data there. So what we found was really that pre-application of Gezagard Dual and Prowl, followed by the full rate of Lorox, really did provide us with greater weed control, more competitive carrots than the other treatments, which was also very evident visually. But it is really important to note at this location, these treatments provide the best results because of the dominant weed species there were pigweed, land squirters, and yellow nutsedge. Prowl is an excellent land squirters product, whereas Dual is the real product you need to use for if you have yellow nutsedge. So I just thought I'd show you some of that work on a large scale that with currently registered products in 2021, those are the treatments that work best at that location. Funding for this large scale trial, it came from Horticulture Crops Ontario, so we greatly appreciate that, as well as we really appreciate all the support from the producer at that location. Okay, so what are our future options? Clarence mentioned these. What's in the minor use system? Goal, which is a group 14, and this would be a post-emergent group 14 at the half the onion rate. Pyridate, which is the group 6, as well as Zidua, which is the group 15, like Dual, and like Clarence said, Tough is actually the same as partner bromoxynil. The future options, the real one that I think we have the most opportunity of hopefully getting, we have to revisit in 2025 to see whether or not Bayer will support, is this diflufenacin or DFF. It is a group 12. We are really in need of a new herbicide group and mode of action for this cropping system, because we have resistance now, we'll continue to have resistance in the future. And so we do need to get something new to mix it up, because the other two new potential products that right now the companies have no plans to bring to Canada. They're group 15s and group 5, which we already have those herbicides groups available in this cropping system. So really the group 12 would be the one that would be most advantageous for the growers. So with what we have, here's an example herbicide program to help manage your resistant pigweed. You can see here, it would be Gezagard Dual and Prowl, followed by early post of Blazer, the bunny ear to one leaf, followed by Lorox. Future products that are currently in the minor use system, this looks similar to what Clarence presented, incorporating Zidua as well as Tough and Goal into your program. It is really important that we continue to utilize as many different herbicide groups in this cropping system in hopes that we kind of hold off any further resistance development of these pigweed species, because they will continue to adapt to our programs. I know that Wendy's on today, and she's going to be, Wendy Zhang will be doing her PhD with Dr. Francois Tardif to work on this group 14 resistant pigweed issue in Ontario. The objectives of her work will be to do a survey, which we will be helping her with, and getting testing. First, any pigweed samples will be tested at the Turnkey Genomics Lab through the project that I'm running for quick tests. And then any locations that group 14 resistance is found at, then we'll go back and collect seeds so that we can do dose response experiments with those, and Wendy can then kind of characterize the level of resistance with the dose response experiment and really determine the molecular basis of the resistance in the group 14, and then identify potential field solutions going into the future. With respect to group 14s, we have had group 14 resistant water hemp in the province for a long time, and there is still a lot of work that needs to happen for that herbicide group with respect to resistance and the basis of resistance. A lot of the soil applied group 14 products still are effective. However, the post-emergent group 14 products are no longer effective. So there's a lot of work that needs to be done there to determine what exactly is happening in the plant to confer that resistance. Just quickly, I'm just going to briefly show there are new technologies, but Geoff and the work at the Muck and Geoff and Kevin and Mary Ruth are doing at this station with respect to robotic technology. These will be options in the future, and they're going to speak more about what has been done so far with the Farm Droid, as well as the Nile Oreo. The Nexus Goat, we had looked at that in since 2020 for two seasons now, in onions, carrots, and lettuce. This one is unique because it actually pulls the weeds out, and so maybe that will end up becoming the rescue treatment after those herbicide products are no longer getting the resistant weed species. You never know, but I do believe going forward into the future that robotic and automated technology for weeding will become really important in this cropping system. We also last year did a few demonstrations with the carbon robotics laser weeder with the help of Kerr Farms and KJ Farms down in Chatham, Kent, Ontario. And mostly it was used in carrots. They were extremely happy with the results. You can see there the carrots that were weeded, they're larger, weeded with a laser weeder were much larger than those that were not. The laser weeder has sub-millimeter accuracy and does do an excellent job, but the general principles of weed management apply. You need to target the weeds when they are small. The heavier infested fields that you have with weeds, the slower the machine needs to go. And it is really quite costly, very, very costly, and it is not autonomous. You still need a tractor driver to drive it. So there are a lot of things that still need to be figured out with respect to return on investment with that technology in Ontario production systems. With that, in terms of the robotic technologies, I'll let Geoff speak more to that, but I did want to highlight the innovation farms and the Ag Robotics Working Group. Some of you may have heard of that. Some of you do participate in the working group that meets every Friday over Zoom at 9 a.m. And everybody is welcome. Funding was received through Farm Credit Canada to establish these innovation farms. And currently, the priorities and what's going to be happening over the next 4 to 5 years at these innovation farms is being developed by the working group. So if you have an interest in technology, like what's been happening so far here up at the Mars, please participate in the group. We're always looking for new members with new ideas that want to bring some new technologies to help Ontario producers remain sustainable both economically and environmentally. With that, I'm going to say thank you. Put up a slide here about a YouTube video that Geoff put together there about new technologies, ag technologies from the FEAR conference and show down in California this past October, and then Ontario funding opportunities there. Thanks again, and if you have any questions, I'd welcome them now. Thanks.
All right, thank you, Kristen. Are there any questions here in the audience? No, if not, we'll invite Katie from Corteva to come up to give an industry update from Corteva.
Okay, hi everyone. I'm Kate Mercer, so I'm the new rep from Corteva, and Phil Emmett was in your territory before, so if you know Phil, I'm taking over for him. So it's a great honor for me to be here today and to learn more about the crops in your territory. I'm based in Guelph, and I know that Alana Respondek, she's our technical expert. She spoke to you last year about some of the new products in our portfolio. So I'm not going to rehash those. I'm glad to talk to you outside at our table, but I'll get us back a little bit on track for timing. I just wanted to remind you about some of the products we have for your carrots and also just bring to light some products that might be important this year. Okay, so these are our carrot portfolio products. So Celebro nematicide is the newest one in our portfolio. So Lana talked about that, but it's a great option if you are planning to fumigate your crops. This is a much safer approach, and it's a really neat novel product that we've brought to the market. So it is available here in Canada this year. So if you're really interested, I know it's available around here at some of your local retailers. So make sure to ask about that. Nutritia N is another great nitrogen stabilizer product that's going to really improve the quality of your crop as well. And then we have our insecticides from Delegate and Closer and Fontellus fungicide. But I have a feeling this year, the insecticides might be the most important product for you to pay attention to. So I'm going to just focus on those for a couple of minutes. But the one part that's great for us is that we have a new insecticide facility in North America. So in Michigan, in Midland, Michigan, we have this massive facility that produces the spinosyn chemical. And what that means for you is that we have that protection when bugs are coming or when bugs are here. We don't have to wait for ships of product to come from overseas. It's just a few hours down the road. So we had the pleasure to take some customers through this fall and tour that facility. And it was really neat to see the state of this art production facility. We actually brought the first farmer ever through. So that was a really neat story for us to bring somebody from the marsh to this American facility. But there they produce the Delegate product through a Gem Velva. That's our new name of that active, and also Success and Entrust. So you know, when bugs are here, we've got you covered with facilities just down the road. So I just wanted to talk quickly about Delegate. So it's been around. It's a great product. We know we can source and have supply. So what that means for you is when diamondback moths, cabbage looper, imported cabbage worm, and flea beetles are here, be thinking Delegate to protect your crops. And Closer. So that's another option for you for carrots. So that would be our aphid product. So if you are seeing aphids in your field, that's a great chance. Really fast acting control with with Closer as well. Also for leafhopper and tarnished plant bug. So we think it's probably going to be a buggy year. Delegate, Closer, talk to your retailer about it, but really nice to meet everybody.
All right, thank you, Kate. And Kate here has a table and a booth, so if you have any interest in talking to her, she'll be here today and tomorrow as well. Yes. So next we have Geoff Farintosh from the research station. Jeff's going to give us an update on some of the ag robots that we've been working on, and sort of just a background of what we've been working on here in the last couple of years with them.
Awesome. Oh, well, good morning, everyone. Thank you all for coming out today. Like Kevin mentioned, I'm just going to talk a bit about what we've done the past year, kind of what our plans for the future is, and also just some of the other robots going around Ontario right now. Tyler right here. So with this group, same issue again. I don't really need to talk too much about the Holland Marsh, but for those of you who aren't aware, in this area, we grow a few things really well. We grow carrots really well. We grow onions really well. And of course, we grow weeds very well. This is a field that kind of got away from us, partially because some of the reasons Kristen mentioned with herbicide resistance, but also just hard to find labor. It can be expensive, it can be unreliable, and people looking for solutions for all different areas have thought that maybe robots could offer that. There's all kinds of different options right now. Everyone's trying to figure it out. We use the example that back in the day, it's kind of like the first cars. In 1908, there were 253 different manufacturers, and then 21 years later, there were only 44 left. And of them, 3 of them, Ford, GM, and Chrysler, were making 80% of the cars. So same idea with robots going on right now. Everyone's coming out all these products, but we're trying to find what ones are going to be the winners. In 2022, we had a couple here that some of you might remember. We had the goat, La Chèvre, as Kristen mentioned, but it started to have some difficulties working in onions and carrots, trying to build that model up. And then we had the Nio Dino, this autonomous tool carrying robot, but because of its form, it was kind of limited in what we could do. So NIO has since ditched this design and they've moved on to one called the Oreo. And the Oreo is a lot more flexible, again, autonomous tool carrying robot, but you can see it has a 3-point hitch where you can add on different implements, charge up, set to go. It's quite a bit faster too at 5.5 kilometers an hour. So when we first got it, we just wanted to make sure it was working, and we had it going up and down the field, just drawing straight lines. It's super accurate. You can just take the beacon on top. I had these little stakes out here and told it where to go, just make a straight line from one end to the other. And you can just see as it worked along, it knocked down every other stake perfectly. So then we could follow behind. In this case, we were transplanting onions. We don't have GPS on our tractors, so it helped us be a bit straighter than normal. And I also used it when I was planting carrots. So I'm driving along there. I just had it kind of one row ahead of me, making a fresh line that was easy to follow. And once it had those maps in later in the season, we could use it to weed. So we put a cultivator on it. But if our lines weren't perfect, sometimes it would have to adjust. So we had this camera guided hitch. You can see the camera at the top of the frame there. And then on the back side of the hitch, you can see this piston that just kind of moves the whole implement back and forth. And the camera, it sees this, and you tell it what color it's looking for and roughly what the spacing will be, and it tries its best to fit a line. We tried this in areas where there were barely any crops coming up at all, and areas where it was pretty thick with weeds, and it still did a good job in both scenarios, finding the middle and keeping the implement in the middle of the row. After that, we started working on a sprayer for it. We had these 2 tanks at the front. You could have 2 different products, and you can see the boom on the back here. And again, we had 2 sets of booms. Early on, we were just playing around, spraying some carrots on, or some water on carrots because it was so dry. But later on, we kind of turned into a band sprayer setup where we could spray both on the crop, but then also have a non-selective in between the rows. The problem with this is if we're just letting it go and something goes wrong, we don't want it just puking out pesticides in the middle of the field. So we added on the Raven control module. This would also turn on and off as it was turning around and set the field bounds. Based on our speed, it could modulate the pressure. And a lot of this year was just kind of getting this robot set up and going. So we didn't do a lot of comparisons, but now next year we want to compare it to a tractor, see what the man hours are, how effective it is, and what the return on investment is going to be. The other robot we had was a bit more ready to go right out of the box. This is the Farm Droid FD20. This robot is really just for seeding and weeding. We had it working in onions, and it goes along, drops the seed in, and then it remembers, or geotags each seed, we say remembers where it was, so then it can come back and weed around each seed within the row. This robot's solar powered. It'll just go out there almost all day long. When we were seeding, we had 24-hour days, but it's very slow, like not even a kilometer an hour at top speed, and we often didn't even run it anywhere near that fast. Because it's so slow, it's handy that it has an app. If something goes wrong, it's in the middle of the field, you can restart it or try to figure it out. But before we put it out there, we just wanted to play around with it here on station. We did a few different trials playing around with the best way to seed onions. The seeding unit's very simple. I just want to point out the seeding disc here. This one just has 5 holes, goes along, drops it through. Whoops. And then there's a seed valve that releases it, and then the sensor to make sure it's there. And that's kind of when it's geotagging it. So at first on the left here, we just did just that. We just did a single row, 3.4 centimeters between seeds. This was try to match the population or get close to what a double row would be, which is what most growers are doing here. But even still, it's not quite the same. And then we tried doing a triple cluster. So for this, we put 15 holes instead of 5. And then I guess to go back here, we would only have it open for every 3 seeds. So we basically tricked it into doing 3 seeds in each hole. So at the end of the season, when it came harvest time, this is kind of what our onions looked like. In the single row, it was tight, and there were a few onions that kind of got squished in there. Even our double row or conventional was maybe a little higher population than we should have. And the triple row, they pushed out nicely, actually, and we had some really large onions. This is the onions per meter between the different ones. And you can see the conventional has more than double the amount of onions compared to the triple. But when it came time to yield, there were actually no significant differences in yield because those onions got so much larger. You can see the triple had way more jumbo onions statistically, and both had much more large onions compared to the conventional, which was mainly medium onions. In the grower field, though, we did 7 acres. We just played it safe. We did that single row with the onions quite close together. And with the onions so close together, that little seed valve is clicking super fast, every 3.4 centimeters. And it sounds like a machine gun as you start to increase the speed. So we tried planting at different speeds, but if we started to go too fast, it would start missing. So with the onions that close together, the fastest we could go was like 225 meters per hour. But that's what we did. We played it safe and slow, and the whole field came up great, you know, laser straight lines of onions. And then we could switch the robot over to weeding mode. So because the onions were so close together, we couldn't use the active weeding arms, but we could use these passive ones. It comes with these wires on it, and they were okay at picking up the onions, but they'd kind of drag them along, and they could start to push soil over onto the onions as well. So there's definitely room to improve this tooling. In terms of weed control, this was kind of our test plot compared to what the grower had, and it didn't do as well as conventional treatments, but that's something we really want to work on in the future. It kept plugging away though until it got to the point where it was really the onions were getting too big for the robot. You can see in this picture, this bar we can raise up, but this front wheel, this third wheel, caused a lot of issues. So in the future, I think for this year, we're going to have one with 4 wheels. So we won't have to worry about that. And hopefully we can run it a bit longer within the field. There were no significant differences in onions per meter marketable yield or percent marketable between what the grower had and what the robot had seeded. So that's a really good starting point, and I think it leaves a lot of meat on the bone for us to improve it further and hopefully even get better yields than what you might be getting otherwise. So for that future work, with the farm droid, we're gonna have the 4 wheels instead of 3. We're gonna try and improve tooling. The guys at Haggerty have built guards and also some different blades to go on the passive weeding, and then trying to figure out that seeding method. So we might try planting a much larger area of those triple clusters compared to the single row this year, and that should also allow us to seed much, much faster. With the Oreo, we're going to do those comparisons. We talked about the seeding implement. I'm not sure if we're going to get that organized, and we're going to have it working more in onions and beets this year as well. Since they have a little bit of time, I'll just briefly mention the Piquetta. Tomorrow we'll do a demonstration of this. This is their lens leaf evaluated nutrient system. And basically you scan a leaf. Right now they have it working in potatoes. It shines light through it, and based on the information that comes back, the different wavelengths, it tries its best to figure out the different macro and micronutrients. And they find it works pretty well in potatoes, but we're trying to get to work in onions next. So we've been doing samples. They're building a model. Still has a good way to go, but we're starting to get there hopefully. Some of these Kristen already mentioned, some other projects going on. This one is built by Karachi. It's just kind of an autonomous platform again. They're here in Ontario. This one was used for scouting lima beans, seeing where the weeds were so they could apply herbicide on those high density areas and also avoid them during harvest. They thought it would be easier in post-processing. On that same robot, they also have electric mowers they've put on. Kristen already talked about the Nexus. They've really focused on lettuce right now. That's where their model is best. So they want to focus on getting that to work really well before they start moving back to onions and other crops. Similar to the Oreo, there's also the TED. This one works in vineyards. Kristen already talked about the laser weeder. I think one of the big differences with them is they are getting better at choosing how much energy they need to put on each weed. And if they can kind of get that range better, it works a lot faster. And they're saying they've almost doubled their speeds. So it's still hard to stomach for a lot of growers, but if they work in the right direction, maybe one day. Another robot that we have in Ontario now is the Burrow. This one's just kind of a tool carrying robot. You can set it to follow you or go in front of you. You can set a path. They'll use it in table grapes so the workers can pick, hit a button, send it off to the truck. When they unload it, they hit a button, it goes back to the growers, and so on. Around here, something like this might be a bit small unless you're in a greenhouse or something. So University of Waterloo has basically a much larger version. They call this the Watano truck. And it's based off their Watano bus, which is this autonomous bus they have driving around campus. Except right now, for safety reasons, there has to be someone in the bus at all times. Another autonomous one, this one a little bigger, is the Agroncelli Roboti. This one's putting in potatoes. So with our Oreo, it can't always carry the same implements. We can't do a traditional carrot seeding setup, but you might be able to get away with it with something like this. And even larger still is the Raven OmniPower. Haggerty's using these for fertilizer application and a few other things. Another one that I think is really interesting looking that's coming is this Tavel apple harvesting robot. And it has a bunch of basically little drones wired to it. I got a better picture here. That'll go up and pull the apples and drop them in. So there's a lot going on. I think it's really interesting to try to figure it out. And if you have any ideas or thoughts on any of these robots and how they might work for you, we'd love to hear them. And with that, I'd just like to thank everyone for being here, and Haggerty, Mafra, Piquetta, all people who made this work. And I'll open the floor up to any questions.
Any questions for Geoff? Clarence, yes.
So if you use the robotics, just focus on resistance management, so you put the herbicide down and any escape session out, the machines are a lot faster than the field.
If we have it like focus on a specific crop within the field, you mean?
Well, so you had- Control all the other weeds and you just let the machine go in and clean out the escape resistance.
Yeah,
Yeah.
Really fast, like much faster.
for the farm droid, will
The
it be
Oreo.
solar power or the Oreo with the sprayer?
This is right now your Tesla, it's a standalone product. That's right. But if you integrate it with herbicides, would that allow it to go faster, cover more acres with the
Yeah, so maybe not for the farm droid, it's kind of limited to that around 1 kilometer an hour. But for the Oreo, there's actually a company in South Africa which has blatantly copied our design for the sprayer, but they've also implemented that green-brown technology, so they can also target specific weeds if they want to. And then, yeah, they can move much faster through the field if they're only targeting a smaller amount. Yeah,
Those all work by GPS.
yeah, both of those systems have GPS RTKs, so they're super accurate. The farm droid one with the solar panel, it requires a base station set up within like, I think it's a 5 kilometer radius of it. And the other one doesn't need anything. It just works within the field. But on the flip side, occasionally it has problems around tall trees. Yeah. Great.
Okay, thank you, Geoff. So moving on from carrots, we're going to have Kristen talk again in combination with Josh on a beet herbicide management program and what to do now in the absence of any products, I guess.
Okay, hello again, everyone. Thanks for having us. Can you see my presentation slides? Still good? Okay, so like Kevin said, we're going to talk a little bit about the beet situation now that Betamix is no longer available to the growers, and what can we do now, and maybe some future opportunities. Just a little lag here again. Sorry, folks. Okay. So throughout the presentation today, we're going to talk about the current herbicide situation in beets, discussions with PMRA with the loss of Betamix, other actives like Nortron, orthofumicide, and Spinade emergency use, some future herbicide options, talk about metamutron, and some new technologies. So in terms of our current herbicide situation in beets, well, we know we have very few options. These are our pre-emergent options, and I just wanted to put another little plug-in for the Crop Protection Hub. What you're seeing here is going to be a new feature that's going to be available to you in the Crop Protection Hub with respect to being able to select your crop and your weed spectrum, and then you can pull up, an efficacy table, basically, and you could print that off or save it and create your own sort of book of efficacy tables for the different crops. So here we have what we have available for pre-emergence options in beets. Really, pyramid is not used. It's a very temperamental product, but dual is always going to be there for your mainstay pre-emergence application timing. With respect to post-emergent options, it does kind of look like we have a lot when we pull up post-emergence options for these weed species. However, again, there's pyramid not really used. Then we have Betamix, which we're not going to have available any longer. Then we have, Lontrell. Well, this one, is good for certain weed species like mustards and Canada thistle, but it's not really good on the majority of broadleaf weeds that we have in the marsh. So it is available, but it's not really have any efficacy on the weeds we're trying to target. Then we do have AIM, which is a product. It is a Group 14 post-emergent product that, you know, you really have to get those weeds when they're extremely small. I'm talking pinhead to cotyledon to one leaf stage in order to get good efficacy. And then you have this, a whole bunch of these acid-based products that were just registered over the last couple of years that, you know, they act as burn off, so you do need a hooded sprayer. They act similarly to products like Ignite, but again, not a lot of use of these products here in the marsh. I'm going to pass it over to Josh for the next 3 slides so he can talk about all the work that's been going on, talking with PMRA about the loss of beta mix and what we can do now. Go ahead, Josh.
Great. Okay. Mic's on. So good morning. My name's Josh Mosiondz. I work as minor use coordinator with the ministry, and Kristen there. Just lost. Oh, no, we're going to stay on Kristen's screen.
Oh, sorry, we're gonna stay on Kristen's screen?
I'm just going to present on 3 of the slides and I'll throw it back over to her.
No problem.
So the challenge here, though, as most are probably aware, is that Betamix is no longer available to the Canadian market right now. This was a Group 5 herbicide with 2 actives in it, fenmetifam and desmetifam. And in late 2022, we found out that Bayer was winding down availability of the product due to some challenges with the formulation. Essentially, what it comes down to is one of the key ingredients they use for this product or for the manufacturing purposes of it is no longer available. And despite the company's best efforts, they haven't been able to find a economical source for this active, or it's not the active, but the formulant for it. So as a result, we haven't had new manufacturing of this product since 2022. And last year was kind of last year we saw the existing inventories dwindle down. So as we know, beets are notoriously intolerant to most herbicides, and it's kind of left us in a bit of a pickle here in that, you know, it's a really niche space of finding herbicides that are tolerant on beets. So for now, the label is maintained, but what it comes down to is that there's just no longer any product available in the market. Further complicating this is that there is also a special review that started on desmetifam, which is one of those active ingredients. So it's unknown what this is going to look like going forward is what it boils down to about availability of Betamix going forward. So we do know the special review is linked to dietary risk, and this is scheduled to have a consultation come up in 2028, likely in the first quarter. But for now, like I say, it's not looking great for this active ingredient and for this product while Bayer kind of works their way through that. Next slide, please, Kristen. So the next thing we kind of pivoted over to was looking at a product called Nortron. Most are probably familiar with it. And the active ingredient there is ethylfumicate. This is an old PMC project that was selected back around 2012, actually on beets, as well as on carrots, I believe in 2011 or 2013. But it's currently registered for use on sugar beets and salad farms in Canada, and we were really hopeful we could actually see this come to market in the last couple of years, especially when we had the issues with Linuron last year with availability in carrots. We were going to try and fast track this submission, but lo and behold, don't we find that PMRA had actually initiated a special review on this one in December of 2022 as well. So this has been linked to environmental and health risks, to exposure of some of the transformation products, and it was triggered in-house by the PMRA when they were reviewing these minor use files. So we're kind of in a hold period for this one as well. And further to that, the cyclical reevaluation is also supposed to begin for that in sometime between April of this year and March of next. So again, the outlook's not great on this product either. The risk cup is apparently full based on the current uses on sod farms and sugar beets. So we've been kind of told that this probably isn't going to be a great solution to fit the gap either. So unfortunately, it doesn't look like we're going to be able to pivot to Nortron. And I hate to say it, but there's likely a good chance that these minor use projects will probably fall off the radar as well as a result of these special reviews or the reevaluation, which is unfortunate. Next slide, Kristen. So this leads us to now looking at other alternatives. Right now, Quebec and Ontario, we've been working together to try and find an alternative. And our best solution right now is looking like a product called Spinaid. Some of you may remember this product being registered in the early 2000s in Canada, and this is essentially half of the beta mix formulation and contains penmetifam. Was previously registered, as I mentioned, and it expired back in 2003. And currently it's marketed by Belgium USA, but with it previously being registered by Bayer Crop Science, we're kind of working with both registrants right now to kind of chart a pathway forward for this. Our intentions right now are to proceed with an emergency use request for this year, and Quebec will be the lead on that one. But we're hoping to get this submitted in about a month's time or so to work its way through the PMRA and hopefully get us availability of a label by hopefully late May or early June, depending on when it goes in. The conversations are kind of underway, and we're just trying to figure out how to get the product here for now, but this is more or less looking like the option we're going to be looking for. So if there is any beet growers in the room, keep an eye out for news on the On Vegetable blog, as well as maybe keep in contact with Matt, as I'm sure he might be your main contact for this once we get this submission sent in. I think that's it for me, Kristen, but I'll pass it back over.
Okay, thanks very much, Josh. So we all know that, Roundup Ready sugar beets have really helped to complicate the table beet herbicide landscape by limiting a lot of advances in this crop group. But, really when Roundup Ready crops were first introduced, it really did change the discovery of new herbicide active ingredients. A lot of other companies just couldn't compete with the price point, and so they focused efforts on looking for new active ingredients with insecticides and fungicides. So there's like a really long period of time when we really didn't see any new active ingredients come to market, especially to Canada. So, but now that we have a lot of glyphosate resistant weeds, I think right now there is 53 in the world, different weed species resistant to glyphosate. It's in sugar beets, for example, it's really highlighted the need for new active ingredients. So actually the sugar beets are going to be really helping us in the overall red beet market, because what can be used in sugar beets typically can also be used in red beets. And so I'm just going to show you there's been some work done in the United States with this product this active ingredient called metametrone, alone or in tank mix with other herbicides. In the US, the metametrone is called Goldtix. And they did get a special approval for use in Nebraska for this product this past season. They did have some good results, and it was mostly to target glyphosate resistant palmer amaranth. But, there was a little bit of a mixed results, good and mixed results, where some scientists did not see really the significant control on the glyphosate tolerant palmer amaranth. But really, we don't really know if it was also group 5 resistant, because this metametrone is a group 5 herbicide, which is same as beta mix, okay? And here you can see a number of different rates and applications have been trialed. And so I wanted just to show you quickly that, yeah, we are, even though it is would be a new active ingredient to Canada, it is a group 5 product. And you can see here where I have the arrows here. This one is where spinade would be. This is beta mix right here with the desmetafim and the fetametafim. But then you just have spinade, which is the one active ingredient. And then if you look at the metametrone, it is very similar to metribuzin, that which is, your Suncor-like products, but they are all still group 5 products. And just, I just talked about resistance, and we do have a lot of group 5 resistant weeds in the province. Primarily in the marsh area, it's the pigweed species, but also, there's a lot of group 5 resistant lamb's quarters, as well as groundsel and others. So, we just need to be aware of that, and as we're moving forward. But really right now, these are kind of, maybe a new product that we'll be looking forward if beta mix never comes back online. So there is this product also called Torio, and it is metametrone and ethyl fumicate mixed together. And this is the product that is likely going to be registered for vegetable systems in the United States. Unfortunately, it does have that ethyl fumicate in it, and so we are not likely to ever get this actual product registered in Canada on beets. We'll be lucky to get just the active, the metametrone registered, so maybe the product called Gold Ticks, which I showed you in that first article. Currently, Adama is looking at this metametrone to come to Canada only as a fruit thinning agent. And so we are going to get some product this year from them to do some trials with metametrone on both muck and mineral soil here at the station. But there are no promises at this point at all. They're just giving us the product to take a look at it. They'll want to come and see the trials. And so we've put together, a bit of a protocol in terms of what we want to take a look at this year. All of the companies have said they're going to try to get us the product here to the station so we can get this trial in the ground. So you can see here we have the regular dual, alone pre, metametrone pre, then dual, followed by 2 applications of metametrone. You're going to have to still use this metametrone similarly to how you use Betamix. You're going to need to do a lot of early season applications when the weeds in the beets are small. And so here you can see the different treatments. We're still going to include Nortron, followed by metametrone. We're going to include Spinaid. This is how it's registered on the label in the United States. And then the metametrone followed by the Spinaid. I still wanted to include this Torio, which has the metametrone and ethyl fumicate in the trial because my colleagues from Cornell, as well as Rutgers in New Jersey, they're going to be doing a trial. And I wanted to at least include a couple of the same treatments as they are, so they potentially could use the data for registration. We're going to be working collaboratively on a lot of specialty crop trials, so it's a sharing of data to hopefully get to the end game faster, which means registrations for growers. So really hopeful about this trial. Hopefully we get all the products and we're able to do it, and you can take a look at it this summer during the open house. Well, I guess it's in the fall, but maybe early other times throughout the season, take a look. So you have seen some new technologies. We have talked about the Farm Droid, Geoff did, in terms of what they did last year. But prior to last year, we did take a look at the Farm Droid in both sugar beets and rutabagas with really good results. In the sugar beets, the reason sugar beets and not just regular table beets is because this Farm Droid was actually developed for the organic sugar beet industry in Denmark. So we thought probably should try it out in a trial, with the actual crop it was made for first. And overall, consistent seeding. We had higher yields, more uniform size sugar beets, and higher sugar content. And some of the main issues in the first year of using this Farm Droid was, you really need the field to be prepared very well. It needs to be very clean. And in our sugar beet production systems in Ontario, we're heavy clay and a lot of trash in the field, sometimes going in after corn. So it really couldn't handle that. So that's just something for the future. But here you can see in this picture here, all of the inside of this large field was seeded and weeded with the Farm Droid. The outside headlands were planted with a regular sugar beet seeder. So you can see very nice, consistent seeding and weeding. So the grower was quite happy with that. But like Geoff spoke about, it is extremely slow. It's like watching paint dry. But, I think one of the reasons it did so well in the sugar beets is that integral weeding really broke up the soil crust, because these are heavier soils where the sugar beets are planted. And that's why we got bigger and more uniform beets. So And then in the rutabagas, same sort of thing. The grower there, and I should have mentioned that in the sugar beets, we actually reduced the seeding rate, and did get even higher yields with the reduced seeding rate. The rutabagas, the grower really didn't want to reduce his seeding rate, but was really quite extremely happy with what happened. You can see there in this picture the difference between the farm droid and the conventional. Really nice, nice uniform seeding. That's one thing you're going to get with this robotic technology, is very uniform, straight lines, which really does help improve overall yield. But both producers extremely happy with the farm droid. And one thing about the farm droid that is unique in comparison to some of the other robotic technology is it is totally solar powered. So the company has really solved a logistical issue with respect to being able to charge the robots. Most of the other robots, from Nile, for example, they only last on an 8 to 10 hour charge. And then they need to go to some charging station somewhere. So they typically have to leave the field to be charged to continue working. Some of the other robots like the Nexus, it is a hybrid, so it is both diesel and electric. So they've also solved that issue a little bit. But yeah, so these are all things you need to consider when thinking about the new technology for the future. So in summary, with the beet situation, hopefully we get that emergency use through, so you do have a post-emergent product to apply over top of the beets this season. Going to do some trial work and hopefully get commitment from Adama to bring metamutrone to Canada for weed management in beets, and continue to look at some of the robotic technologies, and I think the Agri Alliance project that Geoff and Mary Ruth and Kevin are working on will be using the technology in beets at some point throughout the 3-year project. So watch for that. Come out to the field days, take a look at some of the work that's going on, and I guess that's all for me right now, and I'd welcome any questions. Thank you.
Are there any questions for Kristen or Josh? Yes, Greg.
And that there's still a label that's still registered, but there's no product. So if anybody was thinking old school chemistry, I don't think that's an option anymore.
So just to repeat that, the pyramid is not available as well in terms of not having any product available, even though it's registered. So
Bruce wants to comment, so I think BSF has the label.
We had no question a week ago, and
right, so from BASF, it's not available.
So I guess my question to the companies is, what do you think? We have those still listed in the crop protection hub. And I like to leave them in there because they're technically still registered, but when we don't have product, it's kind of a question.
Yeah, I think we have one other question, Jeff. No? Oh, okay. Yep, go ahead.
I spoke to a guy in the States that uses rodents for a pre-emerging chemical beets. Have you ever worked with it before? Acknowledgement?
no, we haven't looked at that one yet. I don't believe they're looking at bringing it up. I used to use it. There's no weeds in the field at all. I still got a little bit left.
Could you repeat that for us online? We didn't hear.
Yep, so there's a product in the state, sorry, is it Roeat?
Oh, Roni, yeah.
Roneat, and asking if that was any availability in Canada, but no, it's not.
And just so you are aware, I did ask Bayer about the diflufenicin for beets, and it's too hot. It burns them right off. So that's the new product that Clarence was talking about in his presentation at Group 12. We thought maybe we could try it in beets too, but they said no, it'll kill them.
You're doing your update then, yes.
Trying to snap it to them somewhat.
Yeah. Sorry, I think I closed it.
It's up on the screen. It's gonna work.
Yeah. So down to advance and then the pointer. All right, so we're gonna have Josh Mosiondz give a minor use update for the group today.
Great. Okay. Thank you, guys. I know we're running a little bit late, so I'll try and fly through this as best as I can. But yeah, I'm just going to give a quick update on the minor use program in the past year or so, and give an update on some of the activities we've had going on, upcoming emergency use registrations for this season, an update on the priority setting workshops we had a couple weeks ago. I'll speak briefly to chlorothalonil. I can probably jump over the tank mixing update or just kind of give a highlight there and skip through those. I was going to talk about PMRA consultations, but I might skip a couple of slides there as well, just to kind of save some time going forward. But with respect to active minor use work, there's still quite a bit going on at the PMRA with approximately 525 submissions at various stages of review right now. And of that, about 30% or just under are for field vegetables. With respect to some registrations that came through on vegetables in the last year, we did have a few come through, but not quite as many as last year. Ethro was expanded on field tomatoes to separate the PHI between hand harvested and mechanical, and that was to actually avoid emergency use. We did see Flint come through on bulb vegetables or crop group 307. There's a bunch of uses for sulfur that came through for powdery mildew on various cucurbit vegetables. Frontier came through for dry bulb shallots grown on both mineral and muck soils. We had oxidate come through on fruiting veg. Nimitz was expanded for several of the crop group 1 subgroups. And we saw Nielta come through for 2-spotted spider mite on cucurbits. With respect to emergency uses, we have very, very high demand yet again this year. Last year was interesting in that I was reviewing my slide for this, and it was a program high for the last decade at least, if not ever. And again, we're on track to beat that number of submissions again this year. So I've got quite a few listed on the slide here, but that includes Captan for management of anthracnose on field peppers. There's several submissions coming through for cabbage maggot on rutabaga and crop group 5 head brassicas. And that's to address the hole left behind from the loss of Lorsban. And I guess the other one that might be interested for the growers in the room here would be also spinade, like we talked about, and success as well for management of cabbage maggot on rutabaga. So there's lots on the go with respect to product submissions under development right now, and we're hoping to push a bunch of these through over the next month or two. So again, I'll put a plug through for the On Vegetables blog. We'll be communicating these through that. And if there's questions on this after that, we can talk about that perhaps after the presentation's done. Lastly, I am hoping to avoid the renewal request for switch again this year. The last couple of years, we pushed that through for management of Alternaria on the crop group 5 head brassicas, but we'll keep an eye on that, and hopefully we can push that through as a full use to avoid the emergency. With respect to the priority setting workshops, we did take place in person again about 2 weeks ago on March 19th and 20th. We did move to a new format with 2 days. So the B elevations were held on day 1 and the A elevations were held on day 2, as well as the regional selections. We did see 37 projects raised to an A, including 5 regional upgrades. There was 2 organic stream products and 30 conventional stream priorities were pushed. Of that, 16 of the A's were pushed by Ontario. So we did have a really good turnout this year. And this list will be narrowed by the end of this month to 23 final projects according to the capacity analysis process. So hopefully we'll see most of those ones pushed through that Ontario had go through. After that, there will be 7 projects selected in September, and those will be through the IR4 program. So we're hoping to see some good lineups there between what the Americans push and what we push for here in Canada. For a quick breakdown, we did see the regional upgrades listed at the top here. BC pushed for aphids and high bush blueberries. The Prairies pushed for a wild oak product on dry beans. In Ontario, we did push for a spotted lanternfly product on wine grapes. Quebec pushed for a phytophthora product on greenhouse lettuce, and the Maritimes pushed for vellum rise on carrots for Rhizoctonia. In the organic stream, we had hazelnuts go forward and cranberries as 2 projects there. And those are likely to go forward as finals as we didn't meet that capacity. PMC wanted to see us push 6 organics through, but at the end of the day, we only had 2. And what they promised is 2 projects for organics. So I would expect that these will go through as finals. For the entomology section, I'm not going to run through all of these, but these were the selections that went forward. There's 10 projects in total. What we're kind of expecting this year is 4 or 5 of them will likely go forward as the final projects according to capacity analysis. There's a lot of greenhouse projects here, but what we've been told is that there's limited capacity there. So 1, maybe 2 projects is likely to go forward in that greenhouse category this year. So this will probably open up some of these other projects to go forward as final projects following capacity analysis. Spidoxanat was a popular product that was chosen this year. This is a new group 23, similar to Movento is what I would probably compare that one to. For pathology, we had quite a bit go through. You'll notice the radish was also pushed with Vellum Rise again. So we're hopeful that between the Maritimes regional selection and through the conventional, we'll see this go through. And what that effectively means is we have the residue data on hand for a crop group registration. So we're going to be pushing hard for that, and that will hopefully get us through the process. Bayer did indicate they want to see this go forward as a joint project, but we've spoken with the IR4 program, and a collaborator down in Michigan is likely to push this through on their end as well. So if it doesn't get picked as a conventional project in the spring here, we're expecting this to get picked back up as a final come the fall. Outside of that, we had a couple alternaria projects go forward with Volpan, and there's a lot of projects that went forward with Floripicoxamid, which is a new group 21 fungicide coming to the market. Lastly, we did see a fenugreek alternaria project also go through. For those also in the room, Floripicoxamid is the trade name for a product called XDE 659. So that was popular in the last couple of years worth of priority setting workshops. And I believe they've done some work here at the station on that. So that's the link with that one. So we continue to see new projects coming through with that. Lastly, for weeds, quite a selection here went forward as well. We did go for both broccoli and cabbage again with Pure Date. So that'll complete the crop group for residue requirements. And we're hoping to push that through. And that'll actually replace the old lentigram label that we formerly had. So we're hoping to get that back. There's a good selection on other crops otherwise. What I can mention is we did look at trying to push for diflufenicin on carrots this year, but Bayer wasn't quite ready to support that this year. So we're waiting for them to make some business decisions on how they want to market that product going forward. And what my hope is that we'll be able to push for that, hopefully at the workshops for next year, as long as we can get company support for that. With respect to chlorothalonil, there's not a lot that's new to this. It's essentially the same slide I had from last year. We had a proposed special review decision come through back in 2022 that proposed cancellation of all field and food uses on this. We don't know what's happening with this other than that it's taken about 2 years to get to this point. So no news could be good news, but we're waiting to hear from the PMRA on this one. What we do know is that there's an update expected with the final decision to come through probably about June or July of this year. So keep an eye out on that. PMRA will likely have more to share with us around then, and that'll give us an idea where we're going with the whole Bravo situation. For tank mixing, again, it's business as usual for this field season, but some of you might be aware that there is changes coming on that one. PMRA essentially released a document back on December 22nd of 2022 titled Tank Mix Labeling. And what they've basically done is asked that all registrants update their labels to say whether or not they can be tank mixed or not. Essentially, it's just a small label update that has to be made, but if they're not speaking directly to it, the label will be considered silent, and then you can't mix that product with others. There's a phase-in period that takes place for this year again, but what I would say is that when you're purchasing product for use next year in 2025, come the winter, just make sure you're taking a look to make sure that they do give comments on the tank mixing situation to make sure you're in compliance still. The good news is that we have seen registrants using what's called the general tank mix statement, which allows for tank mixing with any products that also have that general statement. And it's likely going to be business as usual again for next year, but it's definitely worth checking those labels just to see what's mentioned for that with respect to tank mixing. There's a couple of situations here or scenarios to look at. The yellow ones indicate where you cannot tank mix, but the green highlighted rows are where you can. So essentially just look for those general tank mixing statements on both, or make sure that something might mention specifically what can be tank mixed with another product to ensure you're still in compliance there. If one of the products is considered silent and there's nothing updated on that label, consider that a no, you cannot tank mix on that. But again, we're seeing probably at least 80% of labels being updated already to bring everything into compliance here. So I don't expect this to be an issue like we had originally had concerns about last year. With respect to consultations, there's a lot going on at PMRA right now. Continuous oversight, there's a proposed update fees and a framework for pesticide water monitoring. That's all happened in the last 2 months or so. Coming up is proportional effort as well as the ongoing transformation agenda. But the one that's probably more of interest to the group here is that we are starting to see public consultations go forward with the minor use program, which has never really been done before. So this is rather exciting in that we're getting new products added to new use categories. So there's nothing for field veg yet, but I believe there is a couple of submissions in the queue that'll come up in the next couple of years. So we have seen this happen in the last year or so with 3 different products here: adultamethrin, pyriophenone, and cycloniliprole. So this is good news at the end of the day, and that it means we're getting new products coming out that originally didn't come out for the field use site category. I'm probably going to fly through this slide here, but this is just some current and ongoing minor use issues that we've had. The biggest one is just finding new products, though. A lot of these kind of boil down to that, whether it's the impact of reevaluations, resistance management, or finding effective solutions for some of these difficult to control pests. The reality is that it's just really expensive to develop these new chemistries and get these products in place. So it's an ongoing issue, and we're working our best to resolve that. But I mean, I think looking at the volume of emergency use requests we've had in the last year or so, it kind of speaks volumes to the challenges we're having with finding new products and how quickly we're losing them. So it's something we're currently working on both provincially and nationally, but we're doing our best, I guess, is what it comes down to here. Last one is how you can kind of contribute to the minor use system. It really boils down to communication here. If there's issues you're having, reach out to the Muck station, reach out to crop specialist, myself, and we can try and find a way to find these solutions to get them in place for you. But the biggest factor is when we're asking for help with data generation or use pattern information, how you're using products for reevaluations. This is really, really important information for us to have to refine those use patterns and make sure we can keep these products in place. So if you're tapped on the shoulder to ask for some information, please do consider helping us out on that one, because at the end of the day, it'll help us keep products in place going forward. So my contact information is here. If you have questions, I can take them on the floor right now as well. And other than that, thank you for taking the time to listen.
Any questions for Josh? Yes, Greg.
Just confirm on the tank mix stuff. So that's only for regulated products though, right? That PCP
Yes.
number. So like anybody that's using biological products, like fertilizer.
I mean, if it's a biological product that has a PCP number, it's still affected. But right now it's targeted more just towards PCP product registered. Any other questions?
All right, thanks,
Great.
Josh.
Thank you.
All right, so I'm going to give the last presentation here before lunch. And I'm going to give an update on our carrot research that we've done here on the station the last year. All right. So I'm going to go over some cavity spot screening that we've been doing for like the past 20 years probably, and an update on some Pythium fungicide trials that we've done. So what conditions promote cavity spot? So we have susceptible cultivars. Most of the cultivars we grow are susceptible. Red carrots are especially susceptible. Purple carrots seem to be mostly resistant. And as everyone knows here, orange carrots vary in their susceptibility. Soil moisture is a big issue as well. Pythiums are considered water molds, and high soil moisture increases the risk of disease. Poor drainage, so untiled fields or heavy rainfall sort of in the fall could contribute to more cavity spot. And then cooler temperatures as well. Most time, or the last few years, our falls have been fairly dry and fairly warm, which has sort of led to lower cavity spot incidences in most fields. So we've been looking at this cavity spot screening from Phil Simon's USDA breeding program to look at resistance, and then we've compared these to susceptible cultivars, and then also some popular cultivars that are grown here, such as Celebunch, Envy, and then we're also funded by the California growers, so we're also looking at some cut and peel type, and some of the ones that have been developed have been more cut and peel type carrots. And the overall outcome is to contribute to improved resistance to the breeding stock that'll be available to carrot breeders to implement into their program. We're also looking at differences in leaf blight and forking and bolting as well. Some of our grad student, Umbrin, will talk about this, but there's several species that cause cavity spot, both Pythium sulcatum and Violae in California, and in our area, Pythium sulcatum is also the most. And here's some isolates. Umbrin will go into this, but we have a high percentage of Pythium sulcatum and Violae. So we looked at 65 lines, seeded them on raised beds, and we didn't apply any fungicides or anything to the products. Seeded all with it's all raw seed, trying to get the best germ we have possible. And then we also looked at leaf blights in the fall and also forking at harvest to determine if there are any differences among the cultivars as well. So we looked at in October, we harvested about 50 carrots if we could, and then looked at in December. This year it ended up going into January, where we washed the carrots and then assessed them based on the length of the lesions from 1 millimeter to over 10 millimeter in size, sort of anything over 2 millimeter is sort of a very visible one that could possibly lead to, if you have multiple ones of those, that you would possibly have rejections, especially in the cut and peel industry. And then we looked at a severity index as well. So overall, we had a fairly decent stand in 2023. We did have a higher incidence of cavity spot than in other years. We did irrigate in August, but we had exceptionally low rainfall in September and October, which maybe led to smaller lesions than we had in previous years. And our leaf blight, again, was relatively moderate. And then very few carrots had forking as well. So here you can see some of the cultivars. Deep purple is resistant. And here's some of the cultivars. Atomic red, there's also a Brasilia, which end up having fairly high cavity spot compared to some of the other orange carrots. But there is a group in the bottom here that they're sort of all related, and they do have very good cavity spot resistance. So this is from 2023, this is our severity. So basically very small lesions. So even though they have cavity spot, most people would not really be able to see too many spots on these. And then this is 2022. Again, very similar cultivars. We have these same crosses the last few years. And it's been very encouraging to see that we have consistent results from year to year on our levels of resistance. And here's just a visual. You can see we have a couple carrots that are very light, one light, but the majority of our carrots are clean. So this is one of the crosses. So out of 50 carrots ends up being 12%, but it's very, very minimal in terms of the size of the lesions that we're finding. And then this is the purple carrots that we've been dealing with, deep purple. People have asked, well, maybe it's just a purple carrot. It's very hard to see. When you look at lots and lots of carrots, you're able to tell that whether they're resistant or not. And a few years back, we did have some purple carrots that Dr. Simon had sent us that were actually susceptible. So we were able to see the cavity spot lesions on the different colored carrots. And then here's the atomic red. You can see that same, this is from 2022, but you see these very distinct lesions. Anyone that's grown purple carrots, especially on the muck, or sorry, red carrots, they do get these lesions, and they're very noticeable. This is another one of the 7737B. You can see just very few lesions on these carrots. So here, just looking at some of the other aspects. So we have these crosses, very relatively low incidence, also very little forking. Our deep purple actually had no cavity spot, but it had, we've noticed that it does tend to fork more than some of the other cultivars. And then also varying degrees of leaf blight, but still relatively low in terms of leaf blight. And there are several cultivars, even the atomic red is probably one of the worst for leaf blight. And these weren't really sprayed with any fungicides. I think I had one sort of early on, and then we just let the disease sort of take over. So in summary, we had modest pressure, slightly higher than in 2022. There are several orange wines that have low cavity spot. We have identified these parent groups that have good resistance, and several of them have been actually released to the seed industry that they can start putting into their breeding programs. But there are carrots that are susceptible as well. The uppercut, especially for an orange carrot, is relatively susceptible. And all this information will hopefully lead to better resistance in terms of carrots that we have available to us. So again, looking at the Pythium drench trial, our objective was to look at the new and registered products for Pythium control and cavity spot. We did use a limestone product, and then we put in-furrow applications of either Pibutrinox or Ridamil Gold. And then we did one foliar assessment, and we assessed them for stand, forking, and then yield and cavity spot. So again, we spread the lime broadcast 5 tons pre, and then we're adding the in-furrow insecticides at seeding. We did wait, I think, 2 days before we seeded some of these trials, but you can see there's still lots of calcium on the surface. So here, when you look at percent disease for cavity spot, we ended up with about 50%, just under 50% cavity spot, but no real difference between any of the products, whether we added calcium or just had the products. We did test this Lifeguard, which is a foliar biological product. Again, didn't have any real success with that either. We did have a yield difference, which is kind of strange because we didn't have any differences in disease. But our Ridamil did provide us with a slight bump in yield in this trial. So again, no differences in cavity spot, and the calcium or the fungicides didn't improve control. We're gonna probably look at this one more year. We're probably going to abandon the in-furrow products. This is sort of 3 years in a row where we haven't had any success. We were talking to someone. There's a new silicon lime product, Wollenstenite. Apparently it's carbon neutral, so that's great because you can get it really cheap because they get paid for all the carbon credits that they get from producing it. So we're going to give that a try, sort of as an alternative to what we've been trying in the past. And I'll just give a plug to our research report here. It's available up front here. They're also online, and all the work that we've done is summarized here as well. So I'd like to thank the California Fresh Veg Growers for the funding for the cavity spot work. And then our Pythium work was funded by the Ontario Agri-Food Alliance, the Bradford Co-op, and the Fresh Veg Growers of Ontario. And also to our summer crew who helped with all the work that we've done. We wouldn't be able to do it without with their additional help. I think that's it for me. Any questions before lunch?
Confirm your calcium work there, is that limestone based or?
Yeah, it was gypsum. I think I just noticed that I forgot to change, but yeah. Yeah, we changed it because we talked last year. So yeah, I read when I saw that I didn't, yeah, so we were using gypsum as the calcium form. Yep.
How do you decide what cultivars trials that you're talking about?
Yeah, for our cavity spot trial, most of the varieties are the breeding lines. And then the cultivars, we're trying to pick a mix of what everyone's growing or what some people are growing here, and then also ones that they're growing in California as well, because they want that cut and peel, those varieties, because they're helping fund some of those projects. But in California, they look at like 250 different varieties. We just don't have the time to, like, we could look at all kinds of different breeding lines and all kinds of crosses. And Shawn does the variety trial, so that also he looks at cavity spot in that. So that looks at the 30+ varieties that are commonly grown or new coming up. So that also there's information on cavity spot on those as well, which we'll probably touch on later today. So does someone want to flick the lights? If there's no more questions, we just have a draw for a couple prizes here. So if someone wants to grab the so the prizes are as a result from our sponsors out there and the Bradford Co-op sponsoring some of the prizes. So we got 3 here. Doug, we didn't fill it out. Mark, I did. Okay, very good. Thank you. That's one. That's good. Got 80 ID. All right. So we got one more. Going more. All right, we have lunch, should be ready outside, and we'll convene back at 1:10.
Okay, we'll get going here now. The last stragglers are just finding a chair. Somebody asked me earlier today at lunch how long I've been in this business. And I realized that it's 30 years since I took a leave of absence from my government job at OMAFRA to work for Dason Agricultural Ventilation to test the waters. And as the Remington story goes, for those of you old enough to remember the commercial, I enjoyed it so much, I bought the business. So my name's Doug Trivers. I work for Dason Agricultural Ventilation. We provide turnkey ventilation systems for vegetable storage, and most of you people here would know of me. I was asked to talk about what we can do to do a better job of storing vegetables, and I'm going to speak specifically to carrots, but the same principles apply whether it's carrot, onion, rutabaga, parsnip, whatever. The storage life is determined largely by variables we have no control over. The weather sets the basis of the storage life and the field conditions, what's happening in the field, weather conditions, fertilizing, moisture. But now that the crop comes out of the ground, our objective is to simply maintain whatever storage life was created by the genetics and the harvest year. Years ago here in Ontario, we had a distinct advantage for storing root crops in that we could rely on Mother Nature to provide the bulk of our cooling. And that doesn't seem to be the case. Since the 30 years I've been in business, we can no longer rely on cold evenings at harvest time to pull down the crop. So more and more now we have to look at using refrigeration. So I'm going to speak to what can we do to manage our refrigeration more effectively to get the field heat out of the crop more quickly. What am I pointing this? There we go. So what does the crop need in storage? First thing we have to do is we have to get that field heat out quickly. Most crops won't last more than 4 to 7 days at elevated temperature. What happens is the diseases that are there get a chance to get going, and it's very difficult to stop it once it starts. So the best prevention is to get the heat out so that the diseases cannot get going. By removing the field heat, we also reduce the respiration rate. If we have ventilation in conjunction with refrigeration, we're also removing the carbon dioxide that builds up. Carbon dioxide levels over 4,000 ppm in carrots are detrimental. We also supply oxygen. A potato, a carrot, an onion, they're a breathing organism like you and I. They consume oxygen, they create CO2, and they create water moisture. We have to get rid of that. Our objective is to maintain the storage life, and we do that by managing our temperature and our humidity. If we provide a uniform environment, then we will maintain our product quality. So this is an example, just numbers to give you an idea of the magnitudes of cooling requirements that we're talking about. In a 1,500 box storage, a Bradford box, 1,350 pounds approximately, 1,000 tons of crop. The amount of heat that it takes to remove 2 degrees Fahrenheit from that, it's just math. I want to get into a deep explanation, but looking at the sensible heat that's contained in that crop, to remove 2 degrees over 24 hours, whoops, it takes 12 tons, 12 and a half or 12.8 tons of cooling. If we look at just taking 200 boxes, a day's harvest for a smaller grower, 200 boxes, if those carrots are starting at 65 degrees in those 200 boxes, and we're trying to get them down to 40 degrees, taking out 25 degrees, that's 564 tons of cooling required, or tons of heat contained in that product. So to remove that heat in 24 hours requires 23.5 tons of cooling. That's just to take out the heat that's in the box, or just that's in the carrots. That's not even including the respiration heat. This graph depicts the amount of respiration that carrots are generating. The blue line is the upper level of heat created based on research. There's a publication, the USDA publication 66. It's the handbook for engineers and scientists on how much different vegetable crops generate, how much heat they generate. For carrots, the upper bound is in the blue line, the lower bound is the red line. So what we see here is at elevated temperatures, so if those carrots are at 60 degrees, they're generating somewhere, 1,000 tons of crop, or 1,500 boxes, is generating somewhere between 15 and 20 tons of cooling, up to 40 tons of cooling. Typically, the numbers that we see empirically from witnessing storage operation, the values tend to track about mid-range, a little bit lower than mid-range, except when we get into the deep of the winter. Once the crops are dormant, then I find that these values are actually higher than what we're observing in the field. They're typically somewhere around 30% higher, the research values. The way they derive these values is basically monitored the CO2 production of carrots in storage, and then they converted that to BTUs per hour. So this gives us an indication of what the range of refrigeration. So warm carrots, somewhere between 15 and 40 tons of cooling per 1,000 tons of crop. And once we get it down into holding temperatures, somewhere into that 5 to 15 tons of cooling required to maintain the crop. So this chart is looking at the amount of respiration from our 1,000 boxes. And we have somewhere for going back to my 200 boxes of daily harvest. So each time you bring in 200 boxes, you're bringing in an additional 1 to 4, depending on the temperature they're coming in, 1 to 4 tons of respiration load. And then for the entire 1,000 boxes, somewhere between 7 and 30, depending on the temperature. So at 32 degrees, 7 tons, at 60 degrees, 30 tons. So we have the respiration load, we have the field heat that's in the crop. Our next component of heat load in the building is the actual building itself. If it's a warm sunny day, these values are derived on an 85-degree outside air temperature. When it's 85 degrees outside, 40 degrees inside, 70 degrees outside, 40 degrees inside, the amount of heat from just the building loads, heat coming in from the walls, up from the floor, infiltration, the amount of building load, we call it, is only 2 tons of cooling. So very, very small amount of heat relative to that of the carrots. The biggest building load is the internal load, in this case, 5.2 tons. That's evaporator fans, ventilation fans, lights, that kind of thing. This graph is just depicting the building load, what I call the building loads. And we see here that the largest portion of the building load is basically fans, the internal loads, which are fans, forklifts, and electricity. The walls, the floor, it's almost nothing. Infiltration is the biggest additional load, and that's just air leaking from outside. So if you have a reasonably sealed building, you're going to save a fair amount of the building load, but again, it's a small portion of a small portion. The biggest thing is the heat of the carrots. So this is a summary then of our heat load components of the building. Whoops. So the building shell, 2 to 3 tons. The internal loads, 3 to 5 tons. The field heat, this is just to remove 2 degrees in a day in 24 hours. This is the field heat from a day of harvest. And then the respiration rate. So these are just our loads. So we have a total range, which is it's a huge range. It's going to vary between 23 tons and 47 tons. That's when we add our field heat, so our heat removal, to 28 to 52 tons. So you can see that there's a big range in how much refrigeration is needed for a storage. The ballpark figure we use is 25 tons on a carrot storage. So if you design a system for 25 tons per 1,000 for a 1,000-ton storage, it doesn't leave very much for pull down. We used to be able to use outside air for pull down, but now that we're not seeing the early evening cool weather, we're not able to do it as readily as we once could. So now we really have to look at how do we increase the amount of refrigeration, either adding extra capacity or adding or managing our refrigeration differently. So how do we look at the capacity of our refrigeration equipment? This is a typical chart for an evaporator. All equipment manufacturers provide these charts for the equipment. The take homes on these are for a evaporator, depending on the temperature of they call the saturated suction temperature of the evaporator. There's a variation in at 0 degrees. We have, in this case, 66,000 BTUs per hour that this evaporator provides. In a carrot storage, typically you'd be somewhere around -20 to -30 is what they're designed for. So 57,000. So there's almost a 10% difference in cooling capacity that can be achieved by keeping that evaporator running warmer. Well, how do we get the evaporator run warmer? We get the heat from the crop to the evaporator more quickly. So by adding additional ventilation or ensuring that our evaporator fans are working properly and that our flow in the system is working properly, we can achieve almost a 10% increase in cooling capacity. Similarly, on our condenser coil. So the condenser is the part that sits outside. As you know, with refrigeration, it's a heat pump. So we're moving heat from the inside evaporator outdoors to the condensing coil. If the condensing coil is running at in warmer weather, warmer temperatures, in this case, 95 degrees outside. If it's hotter outside, it's more difficult to move the heat away from the coil. So at the high temperatures, we have 9.3% less cooling available than if it was 85 degrees outside. So on our evaporator, it's important to make sure we on our condensing coils, we want to have our outside air condenser in a place where it's cool relative to there's no place for heat to sink for the sun to create a heat sink. And the other thing we can do is oversize our outside condensing unit. So an outside a manufacturer will provide a table for an outside condensing unit. And then below here would be a next larger size unit selection. So if you're buying new, I would always look at the selection of coils, and oftentimes for the same amount of compressor capacity, and the compressor is the most expensive part of the unit. For the same compressor capacity, you can go down the chart, pick a larger condensing unit, and get 20 to 30% more capacity from that. It's a one-time extra cost, but it's an everyday savings on the use of energy. So our objectives, our biggest objective then is to maintain our storage life. And how do we do that? Managing temperature and humidity. So now once we've selected our refrigeration equipment, how do we use it? So this is just a typical Bradford storage, boxed storage with evaporators in the room. To best get the heat out of the crop, when that air leaves the evaporator, we need to get it to go through the crop before it comes back. If that air leaves the evaporator coil and short cycles and comes back above the boxes, it's not doing anything. It's just cooling the air around the boxes. We need that air to go across the room, come down the wall, and back through the crop. So that means two things. One is there has to be space left behind between the boxes and the back wall so the air can come back through. The other thing is, on the opposite side of the room, there has to be space for the air to get down through the boxes. If you have rows where your last 3 rows where you can't turn, where you're backfilling your aisles, you have to make sure you leave space between the boxes down the length so the air can come back through those and get back into the forklift openings of the boxes and pull back through. So when that air leaves that coil, we want it to go through the carrots before it gets back to the coil. And we will pick up 15 to 20% extra capacity simply by getting that temperature of the air going to that coil being warmer, particularly during pull down. The other thing that's difficult in a, or one thing that's difficult in a conventional refrigerated storage is where do you put your humidity? When that air leaves the coil, the refrigeration coil, it is basically saturated. We've taken storage air at high temperature, low humidity, relatively low humidity, because the air is warmed up as it's gone through the pile. So the humidity has dropped 3 to 5%. We take that cool air, we make it colder. The coil is always going to be at lower than the dew point temperature of the air. Moisture is going to condense on the coil, and the air leaving the coil is going to be saturated. We cannot add humidity to saturated air. So that humidity can only be added downstream of the evaporators. So you want, in this case, the humidifier is directing the air towards the airstream coming off the evaporators. So the two will mix, the humidified air or the humidity stream of air and the evaporator air will mix prior to going down through. It gives the humidity or the air a chance to pick up some heat from the storage before it meets the humidifier air and allows the two to mix. So to help get better air distribution, if we add a plenum, air plenum, and a mixing and a air distribution system to get that air to go through every row of boxes, we get the heat out of the boxes more rapidly and back to the evaporators more quickly. So in this case, for carrots, the plenum slots don't need to be very large. When the air leaves the plenum slot, it goes through the boxes, comes back to the plenum fans. In a retrofit case, the air off the evaporator coils is going to be cycling above the pile, but that air that's been cooled is going to go back through the ventilation system and then be recirculated through the pile. So in this case, when there's a plenum, the boxes are aligned, the air comes out of the forklift openings and it travels between the forklift openings. So every row of boxes is getting conditioned air. That air is going to be humidified and temperature controlled. The furthest carrot from conditioned air is half the distance of the box. This is the other end of that plenum from 2 slides before. So we have fresh air intake doors. So that allows us to get rid of the CO2. It also allows us to take advantage of cooling air when it is available. When in this 1,000-ton storage, when there's an outside air temperature 2 degrees cooler than the carrot temperature, we can get 40 tons, the equivalent of 40 tons of cooling with 20 horsepower of 210 horsepower fans, 20 horsepower of fans. So we can get 40 tons of cooling. When that air leaves, or you can't see it in this picture, but behind this wall, there are 2 fans, 2 plenum fans that are pushing air into the plenum. That air is then coming out through all the through the 5 plenums or 6 plenum slots between every row of boxes. And then also in the plenum, there are humidifiers. This is a system that is designed somewhat differently in that instead of having the evaporator coils distributed throughout the room, the evaporator coils are in the return airstream. So in this case, we have, oh yeah, there we go. We have two plenum fans blowing downwards. So those two fans are sitting in here blowing downwards. So this is our return, this is our fresh air coming in here. And there's a shaft. Sorry, this is our return air. So our return air, after the air leaves the boxes, it goes over the evaporator coils. Then the refrigerated air goes through the return airstream and down through the fans and into the plenum. So in this case, the warmest air from the carrots has to go through the evaporator coils. It has no choice but to go through or past the evaporator coils. So we eliminate all the short circuiting. And in this case, the fans are blowing downwards. The humidified air or the humidifiers are directly below the fans. And so we're picking up the fan reheat that's created by the motors. And we're using that to help add energy to humidify the water. Or to evaporate the water and humidify the air. And it's just another shot from the same building. So that the once the air leaves the rows of boxes, it's the warmest place where the air is, that warm air has come back. This is just an example of a larger storage. Same thing, fresh air intakes, return air. When the return air comes back, so the return air comes back from the storage, and then it's on the other. This is on the other side of this picture where we have plenum fans charging the air down an air plenum, and we have humidifiers mounted to humidify that airstream. So again, the warmest air goes back through the evaporator coils, comes down the plenum, and gets back to the carrots. So to summarize, harvest management is important. If we can reduce that amount of heat that we bring in from the field, we can reduce the amount that we have to refrigerate, and we can get that field out that heat out rapidly. I know we're limited in our harvest time availability. We have so many boxes that we have to get off, but if you can try and find a way to manage the harvest so that the carrots that are going to be kept long-term can be held or can be harvested later and make sure that they're cold, that will help you a tremendous amount in terms of maintaining storage life. We have to get the heat out, and heat removal takes airflow. Whether that airflow is from the evaporator fans or whether it's from additional fans, it takes airflow to remove the heat. And that airflow has to go through the crop. So take a look at your system and make sure when that air leaves the evaporator that it's going through the crop. The final comment I want to make is on temperature differences. Okay, it's a double-edged sword. We cannot move heat if we don't have a temperature difference. So if you're running a fan and you only have a 1 degree temperature difference, you're not doing much work. But if you have a 2 degree temperature difference, you're doing twice the amount of work. So the backside of that is if you have a 2 degree temperature difference, for every 2 degrees of temperature rise, the humidity drops 3%. So now if you have a 2 degree temperature difference coming back, you've got 6% lower humidity. Well, we want to maintain a 95% humidity. So if we don't add additional humidity, we're not going to be able to maintain the environment we need. So I think I've chewed up my time. I'll leave it at that.
Here. Thanks, Doug. Does anybody have maybe one question? If not, that's all good. Okay, our next presenter is Umbrin Ilyas, and she is going to be presenting on management of cavity spot in carrots.
Good afternoon. Today I'm going to talk about our research results over the last 3 years related to the prediction of a disease that's a cavity spot on carrots and its management. Cavity spot is economically important disease. We all know that. And this has worldwide distribution and reported from all the carrot production areas in Canada. At Holland Marsh, this disease has been reported from most of the grower fields. Now come to pathogen is unusual because the disease is caused by several species of Pythium. Throughout the world, these 6 species of Pythium is mostly or frequently associated with the disease. Another interesting thing is that the composition of Pythium species, which is causing the cavity spot lesions on carrot, keeps on changing with the location. So this is very important to know that which species of Pythium is causing cavity spot at Holland Marsh. And this is important because the disease control management, especially the application of fungicide, which is usually the Redomil, it depends upon which Pythium species is present in the soil. Because Pythium sulcatum, one of the species causing the cavity spot, is relatively less sensitive to fungicide as compared to Pythium boileae. So this showing that if there is more Pythium sulcatum in the soil, there is a chances that fungicide would not be that effective. Or if there is more Pythium boileae, so there is a chances that fungicide going to be effective. There are a few management practices available to control or manage this disease. The first one is avoiding fields which have a history of disease. The other one, crop rotation, long, 3 to 6 years. And this is not economically feasible for the area and for the growers, especially like the Holland Marsh, which is producing most of the carrots of Ontario. All the commercial carrot cultivars are susceptible. But with this, there's a little hope that the level of susceptibility of the carrot cultivars varies. However, that variation in susceptibility is still not enough to reduce the disease losses, but still we are looking at it. And for fungicides, there are only 3 fungicides which are registered in Ontario to manage cavity spot on carrots, out of which 2 are not effective, and the one, Redomil, is effective, but repeated use of this fungicide can lead to fungicide resistance in the pathogen and enhanced microbial breakdown in the soil. My presentation is mainly divided into 2 main parts. One is the disease prediction, and the second part is the management. For the disease prediction, we are determining to develop a pre-planned soil test to assess the risk of cavity spot in the field. And for this, we are relating soil properties and soil microbiome with the disease risk. So the high-risk fields can be avoided. The fields at the Holland Marsh were categorized as low and high disease risk fields, and the fields were selected based on the disease history data, which is collected by IPM survey team at Muck station. And all those fields which are having the disease severity less than 5%, we categorize them as low risk fields, and which are having disease severity approximately around 20% based on the disease history, we categorize them at high risk field for these studies. All the fields which are included in this study have muck soil, onion carrot in rotation. A few applied Redomil, but not all, but we take a note of it. And also we noted the cultivar they have seeded. The soil were sampled right at seeding because the aim of this research is that to develop a soil test, which can tell a grower that this field has high or low risk of cavity spot before seeding the crop in the field. That's why we do it right at seeding or before seeding of the carrots. Over the 3 years, a lot of fields have been sampled. After sampling the soil was sent for nutrient analysis to SGS lab and EL labs. And to determine the microbial community, the samples have been sent to Harvest Genomics. The results are showing that all those fields, based on the disease history, which have low risk of cavity spot, have different microbial communities. The low risk fields have different fungi. There are some kind of fungi which are more abundant in low risk fields as compared to high risk fields. Here I mentioned only two. One is the Aspergillus and Mortrella, but there are some more, and we are still looking into that data to find out more information. And again, there are some kind of bacteria which were more abundant in low risk soils. And these bacteria are Rhizobia, which is quite popular. But here I want to mention that not every Rhizobia is abundant in low risk soil. There are some species of Rhizobia which were more abundant in low risk, but the other species are more abundant in high risk. So right now, it's difficult to say that if there is more Rhizobia in the soil, there's a less chances of a disease. More research and more year of data is required to confirm that pattern or to identify these Rhizobia to species level to link with the disease risk. The other one is Chitinophagous bacteria. This is the bacteria which usually degrade the wood. And in the muck soil, this bacteria is already abundant. Similarly, for the pythium, we find that there's some kind of pythium which is more in high-risk soil as compared to low-risk soils. And here, this is interesting that the soils which are having the high risk of cavity spot are having abundant pythium in it. By relating with the disease risk with soil characteristics, here we got very clear differences that the soils which are having low organic matter, high soil pH, and high base saturation calcium are low risk soils. But there is no effect of other nutrients like phosphorus, potassium, and magnesium, and others one. Here having that when the pH is high, calcium is high, the disease is low, it's increasing the possibility that if we add gypsum or lime in the soil to increase the calcium content and the pH, it's going to manage the disease. It's not that simple to say right now, but their field trials are going on at the Muck station, and they are using the lime and the other calcium-based lime and gypsum in the soil to increase the soil pH and look at the effect. Kevin already have given the presentation about it. Sorry. Conclusion for the first part is that low-risk soils have comparatively higher soil pH and soil calcium, and low-risk soils had comparatively more fungi and more bacteria. High-risk soils have more pythium, which is the pathogen, compared to low-risk soils. Now coming to the second part, this is the cavity spot disease management. We are focusing on improving the management of a disease by looking at other options which are available to reduce the losses. The first one is to confirm the relative susceptibility of commercially available carrots. Second, to identify the pathogen which is associated with the disease at Holland Marsh. And the third, to screen these pythium isolates to know if they are resistant to fungicide or not. For the first part, the relative susceptibility of commercially available carrot cultivars, this is an ongoing long field trial at the Muck station since 2015 and still going on. And in the past trials, they have identified some carrot cultivars and categorized them into a category. The first category is resistant. Second is moderately susceptible, and then highly susceptible. The resistant one is the purple color carrot, purple haze, and deep purple. And moderately susceptible includes the carrots which are usually orange colored and mostly seeded at Holland Marsh. And the highly susceptible are the red colored carrots and also two other orange carrot cultivars, that Envy and Tritone. Here I'm showing the results of only 1 year, 2022, because in the previous year, the trend of the data was same. And these results confirm the categorization of carrot cultivars, which are already done at the Muck station, that the deep purple is the resistant one. We didn't find any disease on it. And then the sallow bunch, which is one of the common cultivar, is moderately susceptible to the disease, and propel also, as compared to the red sun. Red sun is the one which is highly susceptible. Another important point I want to make there is the envy, which is an orange color carrot cultivars, but its susceptibility is higher numerically as compared to other orange color carrot cultivars. So this is the one which is highly susceptible. So these results confirm the previous results and categorization of the carrot cultivars. The second, to identify which Pythium species is causing the disease at Holland Marsh. So we should know that which management practices we should opt it, or what is the specific pathogen we are dealing with. Over the 3 years, almost 1,200 Pythium isolates were isolated from cavity spot tissues, and carrots are collected from 18 different fields across the Holland Marsh. And we found 7 Pythium species which are causing the disease. Pythium sulcatum, as we expect to have, and Pythium boile, the other one which is most common in UK, and the other Pythium species. Here, Pythium sulcatum is the one which is the abundant. Almost 70% of isolates were Pythium sulcatum. Approximately 20% Pythium boile, and the rest of 10% is making these species. So the Pythium sulcatum is the one which is causing the disease. Here it leads to the next step. If the Pythium sulcatum is abundant, and there are some researchers saying that it is relatively less sensitive to fungicide, we want to know that if the Pythium sulcatum we are having is resistant or sensitive to fungicide. This is going to the next objective. There are some reports which are showing that the application of fungicide or Ridomil is not effective and not providing the control when applied to the field. And there are some reports from some other areas which are showing that the Pythium, the pathogen, is resistant to that fungicide. So we tested 192 Pythium isolates, which are belonging to these 7 species, mostly are Pythium sulcatum in that testing, and from several fields. The results all are sensitive. Whatever the species we are having, whether they are exposed to Ridomil before or not. So then it comes, if pathogen is sensitive in the soil, why there is no disease control with fungicide? So there is a possibility that there are some other microorganisms in the soil which are degrading Ridomil when we applied it. So that's why it's not controlling it. So this is the possible cause which could be, and further research is required to confirm it. Conclusion for the second part of the presentation. For cultivar susceptibility, purple haze and deep purple were resistant. Atomic red, which is red color carrots, and envy was most susceptible. Sallow bunch and propel were moderately susceptible orange color carrot cultivars. Pythium sulcatum was the abundant one, along with Pythium boile as compared to other 5 species we found, and all the Pythium isolates are sensitive to Ridomil. The overall summary is that the low-risk soils have the soil pH approximately 6.7 and calcium content 83 ppm. sorry, it's not ppm, 83%. Low risk soils had some specific microorganism, but further research is needed to link the specific taxa or microorganism with the disease risk. All the orange carrot cultivars were susceptible to cavity spot, although the NV is relatively more susceptible. 7 Pythium species were identified. Pythium sulcatum was most common. All the isolate tested are sensitive to radiomil, and we are possibly having the non-targeted degradation of this fungicide in the soil. And I acknowledge all the funding partners and the staff at Muck Research Station for facilitating it. And any question? Thank you for your time.
Thank you, Umbrin. Are any questions for Umbrin?
Yeah.
Sure.
Yeah.
Soil fumigation, and kilo stop with it. Or reduce it.
Soil fumigation, it affects all kind of microorganism present in the soil, and possibly yes, but in this study we don't include the soils which are fumigated before seeding, because we want to know if the community is different between low and high risk soils, but I think it reduces the pythium, but other microorganisms too, like beneficial microorganisms. Yeah. Sure.
Carrots don't get seeds.
Yeah.
Red carrots are very susceptible.
Mhm.
Can we not break down the carrot's DNA and genetic makeup to find out what it is exactly in the purple carrot? Move that to an orange carrot,
Mhm.
because if we can find the vaccine for COVID in 6 months and we can prevent us, I think that's species. We gotta start addressing things a little differently, because, and especially with the big weed, all the same thing, you know.
Mhm.
No, I'm just trying to say the genetic makeup is there. You can figure out between one of the different varieties to see what it is, and just focus in on that. You might be able to find better. That's just a thought.
Yeah, very, very nice one.
I'm
And
just wondering why we're not doing any research on that.
yeah, the research is ongoing regarding this, and this is the carrot breeding program, and this is the one program like started, I think, before 2015 and still ongoing. The carrots are breeded, and they are trying to breed the carrots and get more and more resistant one. As you said, the purple color carrot seems a best solution, but for the purple color, this is
They isolated.
the
We know the name of that DNA 107.2. I don't know. I'm just wondering. If they can find out, they can find out.
Yeah.
1,000 years, 2,000 years ago, my.
Yeah.
Can't grow. And if you.
Telling me that there's one carrot season in the US, and it's working on having this spot. And it's taking a lot of progress, but it's multi-systemic, it's not just a single gene. COVID, how many?
No, I know, I'm just trying to say, but everything is a process.
Yeah.
So we did make a lot of progress.
Yeah.
As having presented before. But.
Because all those seven different types of Pythium that you were saying, and the purple carrots against all that, it's fights them all off, so we don't have to just worry about one or two. Yeah, and look at what it is.
They are making progress.
They are.
Yeah, and this breeding process is a bit slow. It's almost, but carrots are biennial, take 2 years to produce seed, and then mostly the seeds are not viable. And yes, that's true. We make a rapid progress for the COVID. The COVID reproducibility rate is so quick, many times in a day, and carrots are taking 2 years. So we hope we got something. Thank you, Margaret, for asking, for providing a detailed answer to it.
One more quick one.
Yeah.
The beneficial microorganisms, was there any specific standout ones that, like Bacillus or mycorrhizae, microderma, that
show a lot of efficacy against?
Yes, we find rhizobium across the years. The rhizobium is the one, but then the problem is that some of the rhizobia species are more in high risk, some are in low risk. So definitely we cannot say about the genus level. We are trying to go up to species level and then provide the exact information, because right now we are at genus level. Yeah, it's hard. I wish if I get a straight answer and I will say yes, but it need more time. Yeah, thank you.
Thank you, Umbrin. All right, our next presentation is going to be by Margaret Alexiou, and she's going to be giving a industry update from Bayer. Yes, sir.
All right. Hello, everyone. My name is Margaret Alexiou. I might know some of you guys, but I was here last year, but I didn't speak. My colleague did. So today marks my 1-year work anniversary at Bayer. And so I'm the fruit and vegetable agronomist for half of Ontario, so I cover this area. Before I get started, I want to introduce my colleague back there. Her name's Sherry Tedford. She's new. She just started in January. And she's our technical solutions agronomist. So she's kind of doing local trials before products come to market. So with products a few years before you guys will hear about them. So the first product I'll get into is Minuet. It's our biological fungicide. So Minuet is a soil-applied biological fungicide. It offers suppression of key diseases, Fusarium, Phytophthora, Pythium, and Rhizoctonia. Some key features of this product is it has a low use rate and it supports early plant establishment and increases vigor early on in the plant's development. So the active ingredient, it's a Bacillus subtilis strain. It can be used in many crops. I've had growers use it in potatoes, beets, and it can be used in onions and carrots too. I just haven't had that experience. And if anyone would like to try it, I'd love to work with you. 0-day PHI, 4 hours reentry. So 1 jug will do about 10 acres at the 379 mils per acre rate. Depending on how you use it and drip, or if you drench it, I might ask you to increase the rate a bit, but anyways, we'll work with that after. So this is how it looks under a microscope. On the left is the untreated, this is a tomato root, untreated just with water. And then on the right, this is a tomato root treated with the bacillus, and you could see all that plant growth, the little fine root hairs growing and all that activity. So you could just imagine what it's doing in your soil. And then just a quick graph. This is some data in potatoes. This was done across the US. And just on average there, growers found a 6% yield increase when they added Minuet into their program. And similarly, this was done in Ontario. Tomato growers found an 8% yield increase when they added Minuet into their program. So just 4 key features I'll talk about right here. It has root colonization, plant growth promoting compounds, induced systemic resistance, and is able to solubilize nutrients. And I could go into depth for that, like for too many minutes, so I'll just skip over that. But just wanted to show this picture. This was done, I had a grower in Bradford use it this year in their beets. And you could see on the left, the untreated, and on the right is the treated with Minuet. It's a very drastic change. We don't usually see this side by side like this, but quite impressive, the early plant growth that we saw there. And then just before harvest, I did like a quality check evaluation, and you could see the difference there between the quality. So that's Minuet. Just going into Flint real quick. I know this is the carrot day. Okay, I'm going to talk about some onion things too. So if anyone has used Flint before, it's the wettable granular product. We are now changing our formulation to a liquid. So that's the only difference. Flint Extra is liquid Flint. So you'd use this in your carrots for leaf blight, Cercospora, and in celery for Septoria and Cercospora. And just when you're purchasing, 1 unit of the old Flint did 10 acres, but 1 unit of Flint Extra will do 17 acres. So just watch your rates and how much you buy. And just because I'm kind of short on time, I'm just going to run through real quick. These are some fungicides that you guys might use or know of. These are both used in carrot and onions. So Luna Tranquility, it's our group 7 and 9 used in onions. This will cover botrytis leaf blight, purple blotch, suppression of Stymphalium. Luna Sensation, group 7 and 11. This is used in your carrots and celery. Get your alternaria, powdery mildew, and cottony and sclerotinia rot. Ilyas, our group P07. This is a really, really good product for downy mildew. This is one of our best products, I would say. It's a truly systemic fungicide, so it moves completely through the plant, above ground and below, and it has really good residual. And then Scallows are straight group 9. This is used in your onions for botrytis leaf blight, purple blotch, and neck rot. So we've got a bunch of different groups, really, really good for rotating your chemistries. And then quick into a few of our insecticides that we have labeled for both carrots and onions and celery. We've got Savanto Prime, or group 4D. So carrots, it will cover your aphids, leafhoppers, whiteflies. Celery for your aphids and whiteflies. Moventos are group 23, registered in carrots and onions. Your aphids, onion thrips, whiteflies. And then Oberon, if you struggle with mites, the 2-spotted spider mites, you could use this in your onions. And then I was supposed to have these ready and printed here to hand out today, but unfortunately they're not ready. So coming soon, we have these guides, the quick reference guides. You open them up, all the products that are labeled on your carrots and onions will be labeled there. And then when you open it up again, it'll have how to use it and all the other key information. So those will be ready soon, and I'll drop them off at the Bradford co-op, if that's a good place for everyone, or I could deliver. I'll see you guys around. So those will be a handy tool in your toolbox. And that's all I have. If you guys have any questions, please ask. And thank you for having me. Greg? Yeah. So it's the same bacteria that was in Serenade soil. Yeah, so there were issues with Serenade soil. I don't know if anyone ever used it, but it used to bung up a lot. And anyways, we reformulated it, but it's 4 times more concentrated with that bacteria. Yeah, that's honestly, you guys, I kind of learned more here today than what I have known, but I think it'll come out between 2025 and 26. But no guarantees it'll be registered on the onions and carrots. It's kind of like a minor use right now. So I don't have more info. Okay. Thank you. Yes. I have not come across that question before. I'm sure it wouldn't do any harm. It depends. Like, is it a different? It might be a bit different bacillus strain. So I think there would be some added benefits there. Yeah.
Not, thank you. And our next presenter is Afsaneh Sedaghatkish, and she will be presenting on celery leaf curl. The down is the advance. And then the laser pointer is right underneath. Sorry. Okay. Here we go.
Good afternoon, everyone. My name is Afsaneh. I'm a postdoc researcher here at Muck Station, working with Dr. McDonald. And my research is mostly focused on canola, but today I'm going to present the work of a former PhD student, Stephen Reynolds, who worked on celery. Yeah, celery is caused by a fungal pathogen, Calototrichum acutatum. Sometimes they call it Calototrichum fruiniae. It's a relatively new disease in Ontario. It was observed first in 2011 and 2012. We fortunately didn't have a really bad outburst in Ontario yet, but in some countries, for example, in Australia, it can cause up to 50% yield loss if the conditions are favorable. So it is causing lesions on the stalks, and we have crown rot, and sometimes the leaves are curled, and we have advantageous root growth, and it's causing like severe yield loss if the conditions are favorable. For example, if the temperature is above 25 degrees, or we have a long duration of leaf wetness, and obviously it's some kind of rainborne pathogen. So if we have rains or overhead irrigation, it can increase the spread of the pathogen. Oh, sorry. Just looking at the life cycle briefly can help us understand how to manage each pathogen. For leaf curl, it starts with the infected celery plants in the field, and the tiny spores or conidia of the pathogen can be transferred to the seeds. So it's also a seed-borne pathogen, which can cause infection in nursery plants. Those plants are transferred to the field. We also have Calototrichum in alternative hosts. It can cause infection on apples and strawberries, for example, and it can cause infection on beets. So removal of infected plants and beets are very important in the management. The best management strategy for leaf curl is use of fungicide. We have 2 fungicides registered for leaf curl in Ontario, Switch and Quadris Flowable. But resistance can happen to both these fungicides because they both have a site-specific activity, which is really important to rotate these 2 fungicides. Other fungicides registered for celery can also be used for leaf curl, but we didn't have any specific study for that. For example, Kristen, Luna Sensation, Flint, or Bravo. But most of these fungicides are from group 11 plus Cordis flowable, and it seems that Calototrichum cause resistance to this group 11 fungicide rapidly. We had to think about the management strategies for leaf curl since it's a new disease in Ontario. We looked at the weather forecasting models, which was used for other pathogens and other crops in Ontario to see if they can be used for leaf curl of celery, in which we can predict the fungicide application or timing, and also decrease the number of application to avoid the resistance. We have cultural practices that can be used. We needed to look for resistant cultivars available in Ontario, which I'm going to talk about more in this presentation. Crop rotation, it's useful for any kind of pathogen, plant pathogen. For Celery, 3 to 4 years would be optimal. As I said, it's a seed-borne pathogen, can be seed-borne. So if you soak the seeds in, for example, 30 minutes in temperature above 50-degree hot water, with 50-degree, it can kill the pathogen. And it's very important to remove the diseased plants and manage the weeds in the field. The first part was looking at the resistant cultivars. It is a 4-year study. I'm just presenting the results from 1 year because it was relatively similar. The left side, we have disease incidence, the presence of leaf curl on a plant in a field. And you can see that some cultivars, for example, mango, blada, hadrian, sabroso, this is the favorite processing cultivar, and Tiza 6200, it's a favorite fresh cultivar of celery that we have. They had lower disease incidence, and if we look at the marketable by yield, they were all similar, no significant difference, only narrow was significantly worse than the other cultivars. But if we compare the results from all 4 growing season trials that we have, cultivars Blada, Tiza 9075, 6010, Hadrian, and Mango were the least susceptible for leaf curl of celery. For the second part, we looked at different forecasting models. We used cultivar Tiza 6200. Also in 2019, we used Kelvin. The forecasting models we used, they were Botcast, which is used for botrytis disease on onions. We used Tomcast with different disease pressure 15 and 25. Tomcast is usually used for general foliar diseases of tomato. SAM, that was for strawberry anthracnose with different thresholds, 0.15 and 0.50 was also tested for leaf curl. And if the fungicide application was recommended by this forecasting models, we alternated Quadris flowable with the rate of 1.1 liter per hectare, and we changed it with switch at the rate of 1 kilogram per hectare. The results were similar. I will show the result from 2019, where we had both Kelvin and Tiza 6200. There wasn't a significant difference between these 2 cultivars, but Tomcast recommended 6 sprays, Tomcast 25 4 sprays, calendar spray 7, and compared to 9 spray when we look at the disease incidence. Tomcast and also calendar spray were quite similar, but Tomcast recommended less fungicide application. Marketable weight, there wasn't a significant difference. If we look at the data from 4 years again, we could see that Tomcast reduced the number of fungicide applications when it can control the disease, and it wouldn't affect the yield. We could also save some money by reducing the fungicide applications. In 2016, it was about $300–400 per hectare by Tomcast, and in 2019, it was between $100 to $500 that we could save per hectare. In summary, for leaf care management, we suggest to use resistant cultivars. Marengo and Blada were the best, but also moderately tolerant cultivars can be used. Tomcast forecasting model can be used for leaf care prediction and fungicide application. As I said, fungicides are effective, but it's important to rotate between the registered fungicide for leaf care, and also we recommend to apply fungicide if the disease is seen in a field. And don't forget to manage the residue and infected weeds. Thank you. I would be happy to answer any questions.
Any questions for Afsaneh? No, thank you, Afsaneh. That's great. Okay, our next presenter is Neem Pandey, and he's going to be presenting on cover crops and soil health. Down button advances. Yeah, the down button advances, and then that's the laser pointer if you want that as well.
Hi everyone, I am Neem Pandey, master's student at University of Guelph with Mary Ruth McDonald and Kimberly Snyder. And today I'm going to present on cover cropping and soil health for organic soil in the Holland Marsh. So these are the objectives for my study, which includes to determine the best cover crop for an onion carrot rotation, best in the sense of controlling wind erosion, and to evaluate different methods of establishing cover crop after carrot harvest, and to assess if general soil health test that has been developed for mineral soil will also work in Muck soil. So for the trial on cover crop after carrots, we use 4 different treatments: barley radish mix, daikon radish, and nitro mix. Nitro mix is the mixture of 6 different species, which includes legumes, cereal grains, and radish. The trial was done for 2 years in 2021 and 2022. And yeah, this is the result we got from our trial. Basically, we measured canopy coverage using a mobile application called Canopio. It measures the proportion of area that is covered by plants or cover crops. So basically, the point here is higher the canopy coverage, lower will be the chance of soil loss by wind erosion. So in our trial, we found no significant difference between treatments in 2022 trial, but in 2022, we found significant difference among treatments. Barley and barley radish mix produced higher canopy coverage when compared to Nitro+ and daikon radish. So this is the picture from 2022 trial. Canopy coverage by barley radish mix, and canopy coverage provided by barley. And this is the picture from daikon radish field, and that one is from nitro mix field. So we can see the difference. Barley and barley radish mix produce higher canopy coverage compared to these 2 treatments. So next trial was on cover crop after carrots. And again, we tried 4 different treatments, which included barley and fall rice seeded after carrots were harvested, and pre-harvest seeding of barley into the standing cover crops. So the trial was done for 2 years again, but in 2022 and 23. So here pre-harvest broadcasting of pre-harvest broadcast seeding of barley into the standing carrot crops were done at a higher seeding rate. It was done at 200 kg per hectare, and the barley were seeded 8 and 17 days before carrots were harvested. And carrots were harvested mechanically, as generally done in the Holland mass. And after the carrots were harvested, the field was rolled and just left. So yeah, this is the result we got from this trial. We found significantly higher canopy coverage in pre-harvest sown barley compared to barley and fall rice sown after carrots were harvested. So this is the picture from the field trial in 2022. So yeah, this is the pre-harvest sown barley's field, which produces higher canopy coverage compared to these other 2 fields. Yeah, this is the close-up look from the 2023 field. This is the pre-harvest sown barley, which has already reached 3 leafy stage compared to 1 leafy stage in the barley seeded after carrots were harvested. So yeah, the conclusion from these 2 trials were like barley radish mix or simply barley is the best cover crop after onions in the Holland marsh. And pre-harvest broadcasting of barley into the standing carrot crop could be a best possible way to establish cover crop after late harvest of carrots. So basically carrots are harvested in October or late November in Holland marsh, which does not provide much time for cover crop to establish after carrots. So we continued with 2 other different approaches except pre-harvest sowing, which included seed priming and transplants, which we thought would be helpful for early establishment of cover crops. So seed priming is just soaking the seeds before they are seeded into the field so that they complete some of their pre-germination activities before they are sown, so that it will decrease the time required for the seed to germinate or emerge in the field. And transplant is just simply growing seedlings in the greenhouse and transplanting them into the fields. So for this trial, we tried 11 different treatments, which included barley, oats, and triticale, primed barley, oats, and triticale, fall rye, daikon radish, and transplanted barley and Alexiou. Barley were about 20 days older when they were transplanted into the field, while Alexiou were about 2 months older, like 60 days older when they were transplanted. So this is the result we got from this trial. Again, barley plocks produce the greatest canopy coverage compared to all other treatments in both years. And among the direct seeded treatment, we see barley produce highest canopy coverage, whether it is primed or unprimed, or all including primed and unprimed other treatments. And Alexiou flocks, they managed to survive but did not establish well to produce greater canopy coverage, even though they were 2 months older. So yeah, this is the picture from the trial. Pictures are sorted from high to low canopy coverage. Barley transplant produced the highest canopy coverage, followed by barley. and the lowest was produced by daikon radish and followed by oats. So the conclusion from this trial were barley transplants were effective as a cover crop after carrots, but may not sound practical at this point. But the point we included this into our trial is to see the possibility if it works or not. However, we don't know, like with the advancement in robotics or other things, if robots can be used for preparing transplant, and transplanting them may be possible at some point in the future. But and we, like, seed priming did not improve the emergence of the cereal cover crops. We did not see like significant use of using seed priming for early establishment of cover crop in the Holland Mass. So another aspect of my research is on soil health. As we all know, like, soil health is one of the most important topic in the field of agriculture, and it is becoming popular since last 2 decades. And there are many studies going on soil health, but all the studies are focused on the mineral soil, not on muck soil. So, and those studies typically show soil organic matter or other indicators that are closely related to soil organic matter as an important or key indicator of the soil health. So muck soil with very high organic matter so we are not sure, like, muck soil is soil with very high organic matter, and maybe we cannot say soil organic matter is the most important indicator of the muck soil. So we are not sure with the findings on soil health that were focused on that were based on the research done on the mineral soil. So this is our one main objective on this part of the study, and another objective was to establish a baseline soil health information so that we can monitor any changes in the muck soil over the long term. So for this study, we collected soil samples from 32 different fields in the Holland Mass. 2 subsamples were collected from each field, and sampling was done in June after fertilizer was applied into the field. And the fields include both onions and carrot fields. And the soil samples were sent to ANL lab for soil health test. They provide a soil health test called Ilyas Soil Health Test 3, in which they provide results on soil chemical properties and also the soil biological properties, microbial properties. So we did that test for all the soil samples collected in 2022 and 2023. Yeah, this is the only one commercially available soil health test in Ontario. This was the reason we chose this lab for soil health test. And also there is another soil health test being developed in Ontario by OMAFRA. They are at the point of collecting or building database now. It is called the Soil Health Assessment and Plan. They are in the stage of building database at this point and collecting soil samples from different farmers in Ontario. The primary focus until now was on wheat, corn, and soybean crop. And the indicators they are measuring is these five indicators basically. And I'm not 100% sure, like, if they also do tests for muck soil, but in their website it is clearly written that the test is given free of cost. So you just need to send samples, filling up a small form provided in this website. So in the fall, when the carrots or onions were ready to harvest, they were harvested from the same blocks from where soil sampling was done. And based on the yield of carrots and onions, fields were categorized into low, medium, and high productive field. Fields with the productivity less than 60 ton per hectare were categorized as low, medium were 60 to 80, and fields with productivity more than 80 kg per hectare were categorized as high. This way we got 6 low productivity field, 15 medium, and 11 high productivity field. So and the productivity in the Holland Marsh varied of carrot especially varied from 28 ton per hectare to 144 ton per hectare. So so we try to we try to correlate the soil properties with the productivity of each fields, and we found productivity of the field is positively correlated with soil organic matter, total nitrogen, soil organic carbon, and iron, which means higher the soil organic matter, higher will be the production, and so on for these 4 variables. And the productivity was negatively correlated with pH, aluminum, calcium, manganese, anaerobic bacteria, and cation exchange capacity, which means higher the pH, lower will be the productivity, and so on. So among these measured variables, soil organic matter, TN, and soil organic carbon, basically they represent similar things. They are highly correlated to each other. So total nitrogen is the nitrogen in the soil organic matter, and soil organic carbon is the carbon present in the soil organic matter. Basically, soil organic matter, higher soil organic matter means higher nitrogen or higher soil organic carbon. So basically they are correlated with each other. So this is further looking into the data. We found like this is the soil organic matter, a carrot yield on the x-axis, and productivity, high productivity field, low productive, and medium productivity field. So we found like low productivity field had soil organic matter around 40% or less compared to other fields. And we also see like most of the fields in the Holland Marsh, high and medium field have soil organic percent more than 50%. So similarly, soil pH was higher in case of low productivity field, except for this field. This field was found to be low productive because of some disease. So yeah, all other fields had pH higher than 6 up to 7.5 about. So and also the aluminum concentration in the low productive field was comparatively higher compared to medium and high productive field. So based on these results, our conclusion until now is lower soil organic matter and higher pH and higher aluminum in the field are associated with lower carrot production. However, increase in the proportion of calcareous clay layer that is behind the muck layer in the the calcareous there is a calcareous clay layer behind the muck layer in the Holland Marsh. So if that calcareous layer is increased or increase in proportion of that calcareous layer in the muck layer will contribute in reducing the soil organic matter and increasing the soil pH, because that is the soil with high pH, and also can also lead to increase in the aluminum because mineral soils are generally high in metals like aluminum. So we are trying to point out that the low production in the field in the Holland Marsh are caused due to the decrease in the layer of the muck soil organic layer. So yeah, this is our prediction until now. So we will continue this study, maybe not by me, maybe by someone, but at this point we have formed a baseline information on soil health of mock soil, so which will be very useful for comparative study in the future to track the change in soil properties and crop productivity. So yeah, I would like to acknowledge the funding and technical support from everyone, and also like to thank Ontario or Mock Station. So questions if you have any.
Are there any questions for Neem?
In your covered crop trials, did you observe any extreme temperatures in the observation period post seeding? Or in other words, were there periods of excess heat and good temperature or very freezing temperature?
Yeah. Oh, he's asking like if I observed any extreme temperature during my cover crop trial in all years. So in 2022 trial compared to 2021 and 2023, the temperature was higher during the last 2 weeks of October, which provided much space for the growth of cover crop. So I guess like that helped a lot to build more canopy and more cover crop biomass in 2022 compared to other years. So higher temperature during the October, last week of October or mid of October until November was helpful in producing higher canopy coverage.
Here's the process. You get some priming on barley and oats and there's like something else there you're using prime seed. I'm just curious, what's the process? I've never heard that in those crops. So how much water and for how long and what temperature do you need to do that?
Yeah, for priming, there are different methods, different solutions used. I used 2 different solutions. One was just pure water, deionized water, and another was water with potassium nitrate solution at the rate of 5 grams per liter. The priming I did was for 24 hours, just soaked in water at room temperature, and then took the seed out and left it to dry overnight before seeding. Yeah.
Are there any other questions for Neem?
But like it is not compulsory to do priming for 24 hours. You can choose like there are studies that shows priming until 12 hours are also like very responsive for barley. Yeah.
Great, thank you, Neem.
Thank you.
Oh, sorry. When you cover crop over top of the carrots in the fall, it said you did it 8 to 17 days prior to harvesting. What made you decide to do it that early before harvesting? Like 17 days before harvest seems like a long time to me. What was the reason behind that?
Yeah, we were targeting about 10 days so that there is a gap, significant gap between the pre and post harvest seeding, and barley will develop to the extent that might not be damaged by the tractor riding during the harvest. But yeah, there are always problem with the timings because of availability of machine and all the things. So So I think we were targeting about 10 to 12 days, but it got delayed in 2023. But we were happy, like it was successful. Even like 1 to 2 weeks up to 17 days was fine.
That you want the barley to roll up or harvest, or you just want the seeds there so that harvest yields.
So we wanted barley to get immersed at least. So yeah, I'm not 100% sure, but yeah, we want barley to immerse, I think. Yeah. 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 Yeah, in this trial, we are just looking at that, if it will kill the barley or barley will be able to survive that tractor riding and harvesting operations. Yeah.
Alrighty, thank you, Neem.
No problem.
Lots of interest on cover crops. All right, our last presenter for the day will be Shawn Janse, and he will be presenting on the carrot variety trial, cultivar trial highlights from last year. Yep. Here, right? Yeah, so around here, yeah. All right, just one sec. Yep.
Thank you, Tyler. Okay, so as usual, when I'm up, I'm talking variety trials. So today I'm going to talk about the carrot variety trial from last year in 2023. Maybe. This one? That one. Pressing the wrong one. Okay. There we go. I see the trial on May 25th. We had 33 varieties from 7 different companies. We harvested that up from the 24th to the 31st over that time period. And I did the evaluations a little later this year, but I did them in January. I did it from the 15th to the 31st. I applied irrigation a few times. Was it super needed? I probably could have got away with it, but I just kind of, I would say, babied them along to get them up and get them going, get them established. So we did that 2 or 3 times, usually a little less than half an inch each time. I had good stands and vigor. There was very low weevil damage. This year when we were walking out in the field, weeding, I really didn't find any carrots that had wilted down from being damaged from the weevil. So, and even at evaluation, there was very little weevil damage. I had average to good years. So this year, actually, I would say the yields were a little bit better than what I had seen in the last few. So I was pretty pleased with that. There was a moderate incident of cavity spot, low levels of blight. There was only a couple of varieties that actually kind of had something that you would have been slightly concerned with, but as a whole, blight wasn't too bad. But we did find the carrot tops themselves to be a little more on the weaker side when we were doing the harvesting. They were snapping off a little easier. Some of them were being left by the combine when we were trying to pick them up. Average lengths overall, a little disappointed in that. Thought they might have been a titch longer. Good color, even though there was some slight unevenness, a few varieties here and there, you saw slightly different patterns of color when you looked at different individual reps. And there was a few cedars found in the trial too last year. Looking at percent marketable, this is like really close. The cellulose trial average was 78.2. It ranged from 87 to 61. The jumbos were 80.7, ranging from 84 to 67. But the main thing here is the cellulose increased in percent marketable by about 3% compared to last year. And jumbos increased in percent marketable by about 5% compared to last year. And that's a trial average, of course. But the varieties that had the best percent marketable when all said and done at harvest, Brilliance. And if you see a number behind the name, that just gives you, it's 2 years in a row now that Brilliance has been in the top percent marketable. So anywhere you see along going forward, just keep that in mind. But Brilliance in the cello variety had it at Stokes at 83.3, and then in jumbos, Baldito from Bejo at 85.2. The next best was Junction from Bejo at 84.5. Numbered variety from Seminis at 85.1, and apparently this has been named Silver Star. So in case you see that, or if Bridget's talking to you, just so you know. And Istanbul was the third best one in the cellos at 83.3, and Katona, second year in a row that it was up in there also, from Seminova at 84.6. And the last one, the number 4, as far as the cellos go, everyone knows 2384 is becoming a little more popular at 82.7, and Berlin from Bejo at 84.3 in the jumbo category. Looking at yield, trial average was 1289 in the cellos, so pretty reasonable, but it ranged from a low of just below 1,000 at 976 up to 1660. Now, when you see this number, everybody goes, wow, that's crazy. With us, sometimes seed placement can come into factor. Also, when we're only harvesting a small amount, an extra carrot or two sometimes coming up in the harvest can make a big difference on bushels per acre also. So you have to use this all as a comparison. But we basically saw this year an increase of about 250 bushels per acre in our average total harvestable yield out of the cellos. In the jumbo, trial average was 1429. It ranged from 1,000 to 17, and it was an increase also about 200. So we did see a general uptick in bushels per acre this year. And I think that was fairly noticeable at grower field day already. You could see the carrots were sizing quite nicely. They maybe didn't quite have the length, but the yield, the thickness of them was there. We could see it then. So I wasn't too surprised to see this year that it was quite a bit better. Looking at the ones that had the best yield, Brilliance from Stokes at 1419, Belgrado from Bejo at about 1529. Nevado, so Nevado here, it's been 6 years that Nevado in the cello type has been in the top yielding carrot for cello varieties that's been in the trial work. So at 1473, the numbered variety 5904 from, sorry, that's not from Bejo, that's from Seminis. From Seminis at 17.19, and that's again Silver Star, called Silver Star now. And just a side, a side note too, Nevado is what we actually grow over at Jane Street on our more marginal land over there. And we've been having pretty good success with that. We're quite pleased with it over there. Apricado, I was gonna say it wrong. Sorry, Tony? Apregio, thank you, from Villemorin at 1438. It was previously known as VAC 111, and Baldito from Bejo at 1626 in the top yielding. And the last one, MV, everyone kind of knows MV 1422 bushels, and Berlin from Bejo at 1496. And again, Berlin, it's 4 years now that's been in the top yielding within the trial in the top ratings. Looking at oversize, so that's anything that was over 1 3/4 inches in diameter at the top of it, at the crown. So in the cellos, of course, we're wanting that in the jumbos. We want them to be big, thick tops, heavy crowns, big, thick carrots. And in the cellos, sometimes it's just nice to know if you've got something that's got potential to be sort of a cello jumbo type of carrot that you can kind of have a bit of a mixture with. So in the cellos, the ones that had the highest amount of percent oversize, Trophy Pack, second year in a row, it's been in the top numbers there at 46. MV from Stokes at 45, and 2384 from Stokes at 41% of the carrots being oversized. Trial average was 36. And just you can see down here, cellos and jumbos increased compared to 2021 and 22. So we did see a bit of an uptick also there. Again, we did see size increase, so it's not surprising to see the percent oversize also jump up a little bit. And in the jumbos, that 5904 or Silver Star from Seminis at 78, Berlin at 78, and Baldito at 75% of the carrots being 3/4 inch or greater when it was evaluated. And the trial average was 64.1. Now looking at qualities or things that we rate the quality of them on. So it's based on such things as uniformity of shape, width, length, appearance, internal and external color, brightness, resistance to green, The trial average was 6.88 or average. Little disappointing considering, you know, the yield was good there. There was a good amount of carrots there, but when it kind of came down time to do evaluation, it was a little low. We would like to seen a little better. It ranged from 5.8 or on the poor side to 8.17. Quite nice, quite excellent. Quality was slightly better in the cellos, which generally is the opposite. Usually I see quality a little better in the jumbos, but this year it was the opposite. Jumbos suffered a little bit. They didn't come out quite as nice, and the cellos were looking a little nicer. Top 6 varieties with highest score, and the cellos were Fertito from Vilmorin at 8.17. You can kind of see too, it's a slightly little more of a tubular, probably got some nant blood in there. And the jumbo types, Caltona, second year that it's been up in there from Seminova at 7.71. Brilliance from Stokes, second year again being in the top scoring at 7.1. Trialence at 7.54 from Stokes in the jumbo category, and Narvek from Bejo at 7.5, and Novato from Bejo at 7.19. So all those ones that had the better quality looking of the carrots when they're all said and done, looking at all the various things that we look at there. Cavity spot, as I mentioned, was sort of there. The trial average was 60.5 with a light to medium-sized lesion. So light being 1 to 2 millimeters, medium-sized lesion being about 5 millimeters in size. It ranged from a low of one variety only having 40% of the carrots with a light cavity spot to one variety having 90% of the carrots having a medium-sized cavity spot. It's the exact same percentage as last year, which was interesting. So 60.5 trial average, exact same again this year. There was an increase in individual spots on the root. So last year, we may have had the same percentage-wise, but this year there's probably more spots on the root. I noticed this year was seeing more of 3 to 4 or 5 spots on each root compared to last year where I was seeing more 1 or 2. So slightly increased. Now that also said, when I evaluated them, I was about a good month later than what I normally would do. So we might have seen a slight uptick in cavity spot also because it's sitting in storage for that period of time. And as we all know, cavity spot slowly but surely gets growing. So something that might have been really, really tiny, 1 mil, has developed into 3 or 4 mils by the time I get a chance to look at it. But the varieties that had the lowest amount of cavity spot out of the trial last year were Istanbul at 40% of them having a light lesion. Naval, and it's actually been in the top lowest percentage of cavity spot now for 9 years in a row. Orchestra from Vilmorin at 53, Novato and Jefferson at 57, all of them in the light. So that's just a 1 to 2 millimeter size cavity spot. And again, the trial average was 60.5 light medium size spot. I just like bringing this up every year because it's just a great thing over the years. Started using XREL in and around in here in 2018 in that ballpark, just have completely obliterated weevil. It's hardly anything at all. Again, trial average for weevil this year was 0. I think I found 1 carrot of all the carrots I looked at that had weevil damage. Just 1. It was amazing. Rust fly, a little tiny bit, and it averaged 1.5% rust fly damage. So a little tiny bit, little tiny uptake compared to say last year, but again, quite low also. So basically our Ramon and XREL, at least here at the station, is doing an excellent job at controlling carrot weevil. It's really not been much of an issue. So then we have adaptation. So I had 3 varieties that went into the adaptation trial. So there's just simply a carrot that may have some possibility. A seed company might be just wanting to try it out, see how it performs here on muck soil to get a bit of an idea. We just basically take a yield sample and do an evaluation on it. We don't do a storage trial or anything like that with it. So there were 3 varieties that were entered. As far as percent marketable, the experimental, keep pushing the wrong button. The experimental number 3572 from Bejo had the highest percent marketable at 87.3. And then there were 2 varieties from Illinois Seed Company at 85 and 76. So very reasonable. All 3 of them were slightly leaning a little bit towards more of a cut and peel. They had longer length to them. I noticed that when doing evaluations. But the one experimental number from Illinois Seed Company 2126 Illinois had the highest yield. And the next one from Illinois is at just under 1,000, and the Beijing was a little lighter at 726. Again, a little more of a cut and peel type carrot, quite a bit of length. All three of them had really good length. Some of them were a little slightly on the thinner side. So I don't know if they're really things for our market, but at least the growers the seed companies are giving it a try to see what they're like. And you can kind of see here, there's your standard foot-long ruler to give you an idea here on the experimental one, how long they got. Quite a length to them. So, but then looking at score, the experimental one from Beijing had the highest at 7.57, considered good. And the Illinois, both of them were slightly above average also. So quality-wise, they were pretty decent there. So then we had the storage trial from 22, 23. So those are the carrots I grew in 2022. Put them in storage in October. Do the evaluation usually in around July, ballparkish. So I had 35 varieties that went in from 7 different companies. And again, storage terms are approximately 38 weeks ballpark. But unfortunately, it was a loss. This is the second time I've lost a storage trial. And actually both of them to somewhat similar type of conditions. They stored very poor. All the varieties had a lot of rot in them. I had a lot of mouse damage. I had mice run through the storage last year, and they did a lot of mouse damage was in there. And we just decided that it was just as easy to let it go. So we let it go. And a similar thing happened probably 20 plus years ago, something similar along the same line. I had a lot of mouse damage. They rotted a lot, and it was just a complete loss. So I apologize, but I don't have any storage trial for data this year. And of course, as always, I just touched on the tip of this. If you take a green book home with you, there's lots of information in there. There's a lot more categories that we do ratings on. There's also a comment section for each variety, just things that I saw when I was doing the evaluations. I make comments down. There's also a season summary, mostly more for the seed companies, but there's a season summary, things that we saw in the trial, patterns that we saw developed. There might have been differences between replicates or things along that line. And that's all in the green book. We have lots of green books on the front counter there. So please make sure you take a copy home with you. And our copies of the green book too are always, if you're interested in looking back at anything, it's on the website. So we got that. We always just like to make sure too, everybody's aware that, we do have a Twitter account for the Integrated Pest Management Program that Tyler sends out little bulletins. Rust flies are peaking, onion maggot fly has been found, whatever the case may be. Muck conference is coming up again. And then they also have a YouTube channel, which I think everybody's kind of aware of now also. So, and on there is the Muck conferences. These programs are I want to say taped, but recorded, and they end up on that website, on that YouTube channel. We have some variety trial stuff on there, things like that. So if you have some time, if you're looking for something, always feel free to go back and have a peek at it. For example, even something Clarence, when he was talking today about all his herbicide things, he's kind of rolling through it fairly quickly. You maybe didn't catch everything. You can always go back to the YouTube channel later on and watch it again or get information, or always contact us too, because we have it all here too. And of course, I don't do this all alone. We have some summer staff. We had Maya this past summer and Adriana help us get the work done. And Tyler came over after Mishko retired to help out on the farm on the side of the variety trials and still doing his IPM also. So Tyler also was a major help in getting the variety trials done this past year. And I'll just quickly touch base. Also, we're continuing on during our trials. And this year too, just for the growers' information, we're going to be doing a beet variety trial. As we know that that's becoming a little more popular, guys are starting to grow a little more beets. I know it's not a large scale production, but there is some beets starting to be growing more and more every year. So we're doing a beet variety trial this year too. So we're hoping to have between 10 to 15 varieties of different types of beets. I'm going to aim and try my best to have it that those are basically about ready for harvest when we have grower field day, the Thursday after the long weekend of September. So we're going to try to seed and try to hopefully get the beets ready at that point in time. So if you're interested in anything like that, keep that in mind. You may want to come out to grower field day to see that at that point in time. Okay, and I think that's it. Is there anything else we need to say for today?
Same time starting tomorrow?
Yep. So we're back here anytime after 9. There should be coffee and donuts for you guys. And at 10 o'clock, we'll fire everything back up again. Tomorrow is what we call the onion day. So we're going to be focusing more on onion type crops. We thank you very much for hanging in, staying here to the very end. We hope to see you here again tomorrow. And if you need anything or have any questions for us, feel free just to catch us afterwards. And thank you very much again for coming.